Welcome, aspiring Kotlin developers. I am thrilled to have each and every one of you joining me on this exciting journey into the world of Kotlin programming. Whether you are a seasoned coder or just starting your programming adventure, you are in for an amazing ride. So, in this lecture, we are gonna set up the IDE. What I'm gonna do is open Chrome and type IntelliJ. We are gonna code in IntelliJ. Just click any link, download the IntelliJ. Great, it's getting downloaded. Wait for a few seconds. So in this course, we will be exploring the ins and outs of Kotlin, a language renowned for its concise experience and versatility. Today marks the beginning of our exploration into the fundamentals of Kotlin programming. Throughout this series, we will cover essential topics like variables, data types, control flow, and more. You will get hands-on experience with practical exercises designed to reinforce your understanding and build your code skills. And fear not, because we are here to learn together, I will guide you through each concept, breaking down complex ideas into digestible pieces. Plus, you will have the chance to apply what you have learned through fun and engaging exercises which you have in the course itself. Remember, programming is a journey and everyone progresses at its own pace. Mistakes are just stepping stones to success. So, buckle up, stay curious, and let's embark on this Kotlin adventure together. We'll wait for a few more seconds. Okay, we have downloaded. Just click on that, open it. Okay, now in Mac you need to just shift it like this in application and you're set to go and you can run the app now. Okay, out, just click on start trial. Start trial. Just send your email if you want. And submit. You put any sort of a mail. Once that is done, come back over here and it's done. Put continue. Done. Now you could basically create a new project. So this is the alert dialog which you will get. Now just click on suppose any sort of a layout, suppose my new project, my project. Make sure it's Kotlin, make sure it's IntelliJ, and then create it. It will take some time, and this is how we are gonna start with our IntelliJ. Great. And this is what we are gonna. This is our project. Just remove this, and this is a new update which we have got in IntelliJ. So here we go. As we wrap up this episode, I hope you are as excited about Kotlin as I am. In the next episode, we will delve deeper into the basics of Kotlin, exploring variables, data types, and more. So be sure to tune in for our next coding session. Thank you for joining me today. Until next time, happy coding. Meet you in the next lecture. Thank you. Welcome to our Kotlin programming course. In this lesson, we will explore the fundamental concept of variables. So if you come over here, and if you see under variables, there are two folders. Go to the src, then main, then in this Kotlin file, you will get a main.kt file. Okay, just go over there. Now I'm going to explain what variables are actually. So variables are like labeled boxes that store information. They have a name, type, and value. For instance, in Kotlin, you declare a variable something like this. So we have var age, int age is suppose 25. Okay, so this is basically, this is the name of the variable, this is the type of the variable, and this is the value of the variable. Okay, now there are several types of variables. Suppose integer value is there, so this is an integer value. For integer we are using int. Okay, now there is a double value that contains the floating values, so it could be something like var weight double is equals to, suppose weight is 65.5, something like this. Then we have a boolean value. Suppose var is student boolean bwo boolean is equals to false. Now string value is also the string type of variable, so string name, string Karthik. That's it. Now if you see, I'm using a var over here. Okay, so this is basically called the mutable variables, which you can change it. Okay, so if I'm suppose writing something as var is there, right, and if I suppose want to change the age, so I could change the age as well, so 26 suppose. Okay, so if I'm using var, that means I could change the value. Okay, now suppose in case I'm using val stands for immutable values. Okay, and if I'm assigning any integer as val, then I can't change it, so it's showing red over here. Okay, so this is one more advantage of Kotlin over Java. We could use var and val, and we could basically explicitly declare it what sort of a variable it is, whether it could be changed or not. We could do it. Okay, so like mutable variables where var is used are declared using the var keyword. This means that their values can be reassigned or modified after the initial assignment. And while the mutable values are declared using the val keyword, once assigned, the values cannot be changed. They are read only. Okay, great. So what sort of a value does val contains? Val could contain such as um, a pi value. Okay, a pi is basically a constant. Okay, so 3.14. So a pi value is constant, it couldn't be changed, so we are using val. But age, weight, and all things we could change. That's the thing. Okay, now congratulations, you have learned the basics of Kotlin variables. They are essential for storing and managing data in your programs. Practice using different types and experiment with reassigning values. Happy coding. Meet you in the next lecture. Thank you. Today's Kotlin programming lecture. In this session, we will delve into the fascinating world of data types, understanding data types is fundamental for writing robust and efficient programs. So let's jump right in. So as we discussed in the previous lecture, we have a data type of integers. Okay, then we have a data types of floating type, that is represented by double. Then we have boolean, then we have string, and there are a few more data types as well. There is a data type called character data type, which is not used much, but so it's like, suppose grade, then char. So this is how we could go with the character data type. Then we have a list data types as well. So how to do it, how to go with the list? So it's like where, suppose numbers are there, number, let's go with numbers. Then we have list, what type of list is it is, what type of data type the list is, the list will contain, it's an integer. Then we are gonna write list of then just assign the values of 5, sort of like this. Okay, so this is the list data type. This is how we declare and initialize a list. Then we have a nullable type. So we are going to explore the nullable types as well. These allow variables to hold either a value or a null, providing flexibility and handling optional data. This is one more advantage of using Kotlin. So how to do it? Such like where, suppose nullable name, then I'm going to use suppose string, then a question mark sign, and then null. So it could either contain a null or a normal string value. If I just remove this thing, see, error is showing over here. So if you have a doubt, or if you have a sort of knowledge that the string can contain a null value, then you could use this question mark and no error will be thrown. Okay, so this is one more advantage of Kotlin. So remember, choosing the right data types is crucial for writing efficient and error-free code. So let's dive into detail and enhance the programming skills. Happy code. Hello Kotlin enthusiast. In today's lecture, we will unravel the concept of type interface in Kotlin. Type interface is a powerful feature that allows the compiler to automatically determine the data type of a variable, making our code more concise and readable. So let's explore how this works. Type interface is Kotlin's ability to automatically deduct the data type of a variable based on its initial value. This eliminates the need of explicitly specifying the type, making our code cleaner and more maintainable. So suppose if I take an example, I'm just going to remove this code, all the things. For var, so let's start with a simple example. So var age is equals to 25, suppose. So here we declare a variable without explicitly mentioning its type. So we have not mentioned integer over here. Okay. The compiler automatically interfers the age is of type int because we initialized it with an integer value. Similarly, we could go with, just copy this thing. Similarly for float also we could do it. So suppose var weight 65.5 or 6. Okay. For same could be done for list as well, collections. So suppose var number list O must be capital 1 2 3 4 1 2 3. Okay, so we have not mentioned over here what type of integer the list is, what type of data type the list contains and stuff like that. The compiler will automatically determine that during the compile time. Okay, now similarly goes with the nullable thing as well. So suppose var nullable name is equals to suppose null. So this is also done by the compiler itself, it's not an issue. Okay, now, and there you have it. Type interface is a fantastic feature that simplifies our code by letting the compiler do the heavy lifting. Embrace this convenience, write more expressive code, and enjoy the benefit of Kotlin. Happy coding. Meet you in the next lecture. In today's lecture, we are going to explore the foundational concept of conditional statements using if and else in Kotlin. These constructs allow us to make decisions and execute different blocks of code based on specified conditions. So let's dive in. Firstly, let's understand the if statement. It's a basic conditional construct that allows us to execute a block of code if a certain condition is true. So I'm just gonna remove this old code. Now, suppose I want to declare a variable called age, and I'm gonna assign the value to age as 20, suppose. Now I have to check whether the age is greater than equal to 18 or not. If it's greater than equal to 18, I'm gonna print that you are eligible to vote. Okay, So the syntax is something like this. So if age is greater than equal to 18 curly brackets, then print ln you are eligible to vote. Done. Just give some space over here. Okay, once this is done, I think we are set to go and we are set to run the code. So let's run the code. Just go over here and press play. It's building. Okay, we could see you are eligible to vote. Great. So in this example, we checked if the age is greater than or equal to 18. If it's true, it prints a message about eligibility of the vote. Now if you see why it's showing yellow over here, right? So this is because only one comment, one statement is there, and we are using curly braces, just showing a normal warning. It's not a big deal. Okay. Now let's use if and else. So the if else statement extends the if statement by allowing us to specify an alternative block of code to execute when the condition is false. So over here only, if suppose the age is not greater than equal to 18, then what shall we print? So suppose if else, just copy this thing, you are not eligible, eligible to vote. Okay. Now suppose I change the age to 15, and if I just run the code again, okay, I'm able to see you are not eligible to vote. Okay. So in this example, based on the age, if it's 18 or older, it prints a message about eligibility. Otherwise, it prints a message denying the eligibility. Okay. Similarly, we can also use if else statement as well. So suppose if I just want to remove it, we can also use else if statement. So suppose let's declare a variable called score, and if score is greater than equal to 90, then I'm gonna print ln, I'm gonna print a grade. Okay. Now suppose I'm gonna use else if the score is greater than equal to 80, I'm gonna print B grade. Okay. Now similarly it goes something like that, and lastly I am gonna use else print below passing grade, suppose. Okay, so here if suppose multiple statements are there, we could use else if over here, something like this. Okay, now just run the code and let's see what's the output of this. So the output should be B grade. So now in this example, the program evaluates the score and prints a corresponding grade message based on multiple conditions. Okay, here we go, B grade. Now there is one more way we could use the if and else statement. Suppose I just want to remove this. I'm gonna declare a variable such as val num1 is equals to suppose 15, then val num2 is equals to 20. Then suppose uh, with these two numbers I need to find which among them is the maximum number. Okay, so how to do it? So I could do something like val max num with less syntax. If I want to do, how to do it? So I'm gonna say num1 is greater than num2. I'm gonna return num1, else it's gonna be num2. This statement means if the num1 is greater than num2, I'm gonna return num1, I'm gonna assign the value of num1 to max num. Otherwise, if this statement is false, that means num2 is greater, and I'm gonna return num2 and assign it to max num. And I'm gonna print ln the max num is, so I'm gonna use $, then just type max num. So this way, this is the way how I could assign a value in the println statement, okay, using a $, over here. Now let's run it. Great, the max num is 20. Great. So, and there you have it. We have covered the basics of conditional statement using if and else in Kotlin. They are fundamental building blocks for creating dynamic and responsive programs. Practice using these constructs to make your code more elegant and adaptable. Till then, happy coding. Meet you in the next lecture. Thank you. Today, we are delving into the versatile when expression in Kotlin. This construct allows us to replace lengthy if-else chain and simply discussion making in our code. So let's explore the power of when together. It's basically a replacement of switch in Java. So let's code days of the week. Okay. So what I'm gonna do is I'm gonna remove the code from the previous lecture. Now we have to print days of the week. Okay. So I'm gonna declare a variable, suppose val day Monday. Now I'm gonna use when day. Okay, so I'm using when day. I'm gonna use, suppose if it's Monday, then I'm gonna print ln. I'm gonna say suppose it's the start of the week. Done. Now suppose suppose it's Friday, so what I could do is I could use comma if there are multiple conditions. Okay, so Friday, Saturday, then I'm going to use println. Weekend is suppose here. And yep, and if I suppose want to use it's a regular day expression, then the rest all the days apart from Monday, Friday and Saturday is a regular day, right? So I'm going to use else. I'm going to say println. I'm just going to say it's a regular day, something like this. Okay, so this is how we can go with the when expression. So if I just try to run it, it should print it's a start of the day. So in this example, based on the value of day, different messages are printed, you can think of it as a concise replacement of series of if else statement. Okay, it's compiling, is taking a little bit of time. Let's see. Okay, it's the start of the week. Great. So let's take a second example. Okay, now what we are gonna do, we are gonna use when expression with range. Okay, so how to do it? I'm just gonna remove these. So what I'm gonna do, I'm gonna use a variable var. I'm gonna use a score, suppose 75. So I'm gonna put a range over here. Okay, I'm gonna use a range. I'm gonna say when score curly braces, when score is in between 90 dot 100. So this means when score is between 90 and 100, okay, between 90 and 100, then I'm gonna print excellent. Okay, and there is a simple difference between print and println. Println is used to change the line, print is used just to print the statement, it doesn't change the line. Okay. Now then again, suppose I want to say in suppose 70 until 90. So this means from 70 to 90. Okay, until means, if you see the expression until means it doesn't include 90, but over here if I use two dots, it's basically including 100 as well. Okay, and until means it doesn't include 90. Okay, so I'm gonna say print ln good job. Okay, now the next thing is else I'm gonna use, and then I'm gonna use println keep learning. Okay, I think we are done. So the score is 75, so good job must be printed. So here's the when expression checks the range of score and prints a corresponding message. It's particularly handy when dealing with numeric ranges. Okay, here we go. Good job. Great. So let's take a third example now of when. So we are going to check the type. Okay, what type of variable it is. Okay, so how to do it? I could say as suppose it's value. I'm gonna use any. I'm gonna say hello world. Sorry, hello world. Now, what is this any? Any includes any variable. Okay. So previously we were having int, string, character, boolean, things like that. But any, if you are writing, it means any variable. Value is the name of this variable, and any is the type. Basically, it's include all the variables. It could be anything. So I'm saying when, if someone is not sure as to what will be the value of that variable, so you could use any over there. Okay. So this is one more advantage of Kotlin over Java. So I'm going to say when value is, I'm going to use is string. So if value is string, then what I'm going to do, I'm going to say println it's a string, right? Then we are going to say is int println, sorry, I'm going to say it's just copy this thing, paste it, it's an integer. an integer, just copy this thing, or else use else. You can use else as well. Else I'm gonna say println unexpected type. I'm gonna write. Okay, done. If you run the code, this should print it's a string, because this is basically hello world is a string, so it should print it's a string. So the when expression is not limited to values, it can also check types, making it useful for handling different data structures. So if you see, it's a string. Okay, now let's take one more example of multiple conditions. Okay, now we are gonna combine all the three conditions which we have used earlier and gonna make it in one. Okay, so let's take a variable called r of day, and I'm gonna say the r of day is 12. I'm gonna say when. So if you see, I'm not putting a condition, or I'm not passing r of day over here. Okay, just simply saying over here that r of day is less than 12, then print. If it's less than 12, then I want to print and then good morning. Okay, now then again I'm gonna say r of day in, suppose, range 12 to 17, so make sure 12 and 17 both are included in this. Okay, r and day between 12 to 17, then I'm gonna say print ln good afternoon. Else I'm gonna print ln, I'm gonna say good evening. Okay, so if it's less than 12, that means good morning. Between 12 and 17, it's good afternoon, and afterwards it's good evening. Okay, so let's see, let's run the app and see what happens. So this should print good afternoon because it's including 12 and 17, so 12 is included, so this is, I think this should be the output. Good afternoon, great. So with when, you can also use it without an argument. As I told, there is no argument over here. Here it checks different conditions based on time of the day. Okay, and there you have it. The when expression is a powerful tool for handling various conditions in a concise and readable way. It makes your code more expressive and easier to maintain. So go ahead, explore its flexibility and leverage its capabilities in your Kotlin project. Happy coding. Meet you in the next lecture. Thank you. Kotlin enthusiasts, today we are stepping into the world of iteration with the for loop in Kotlin. This powerful construct allows us to repeat a block of code multiple times, making our program more efficient and versatile. So let's dive into this in detail. So what I'm going to do before that is I'm going to go to files, I'm going to go to new, I'm going to create a new project. I'm going to say it as for, or just type iteration. Iteration would be much better, I think. Okay. Make sure it's Kotlin, IntelliJ. I don't need to create a git repo. Okay. Add a sample code. Okay, no issues. Create it. I'm gonna set this window. The for loop is a fundamental iteration construct in Kotlin. It's used to iterate over a range, a collection, or any iterable type. So we'll explore all the types of for loops that we could use in Kotlin. Just cross it, remove these things. If you just want to remove this thing as well, You can do it, no issues. Okay, so I'm gonna create a function. What functions are, I'm gonna tell you afterwards. Okay, but as of now, let's go with this. So just type fun. So the first example will be a loop for range. Okay, so I'm just gonna say loop for range. Okay, and over here, how to do it? So I'm gonna say for I initialize one in 1.5. Okay, I'm gonna say println count I, which means I'm creating a variable I which should be between the range 1 to 5. Okay, so first the compiler will try to execute this line, which is initially the I is 1, then again the compiler will come over here, will increment I, and will again come over here. So sort of like this. Okay, so let's run the program. So just copy this thing, paste it over here, and it's done. So in this example, the for loop iterates over the range from 1 to 5. The block of code inside the loop is executed for each value of I in the range. Okay, great. Count 1 to 5. Now if you see, if I just remove over here, it's print ln. If I just remove ln from over here, if I just try to print it, it will not change the line. Okay, that's the importance of ln. Okay, it's not changing the line, right? Okay, so I'm just copy. Okay. Now the second example is for loop with collections. Okay, so I'm gonna create one more function. I'm gonna say loop for loop for loop with collection. Okay, and how to do it? I'm gonna say val fruits is equals to list of apple, banana, orange. Okay, so these are the list of fruits. Now what I'm gonna do, I'm gonna iterate all the fruits. I'm gonna print all the fruits. I'm gonna say for item, suppose for item in fruits. I'm gonna say print ln fruit fruits. Okay, so what, sorry, I need to print item over here. Okay, so what does this mean? So initially I've declared an item as a variable, and it will iterate through all the items that is present in the fruits list. Okay, so first it will try to print apple, then banana, then orange, sort of like this. Okay, now what you do is just copy this for loop with collection, paste it like this, try to run the code. The for loop can also iterate over collections like list. So here it prints each element of the fruit list. Here we go. Okay, now let's go with one more example. This time we are gonna go for loop with indices. So I'm gonna say fun for loop with indices. Okay, so this time I'm gonna create a list again where the colors, list of red, green, blue, right? Now what I'm gonna do, I'm gonna say for index comma color in colors dot with index. So we, from this code, what we will have is the index. Okay, that is the index. So this is index 0, 1, 2, sort of like this. So we will get the index. Okay, so how to do it? I'm gonna say println. I'm just gonna print. I'm gonna say color at index color on index color. Okay, so what is it happening over here? What's happening over here? So what I'm doing is I'm saying I need the index of a particular color. So suppose first is the red, right? So the red value will be assigned to color, and what is the index of this color? Of this red color, it's 0. So this 0 will be assigned in this index. Okay. So sort of like this. So the value, the first iteration would be 0, and then the color value, that is the red. Then the second iteration would be 1, and the color value is green. It's sort of like this. Just to get the index in an list, we could go with this approach. Change it to for loop with indices, and very good. So when you need both the index and the value in the loop, you can use with index this time. Okay, and this example prints the color along with its index. Here we go, 0, 1, 2. Great. Now let's go with the fourth example. But this time we are gonna go with for loop with steps. Sorry, fun for loop with steps. For I in 10 down to 1, step 2. What I'm gonna do, I'm gonna say print ln countdown I. Okay, I forgot to add this. Okay, great. So what this code does is, so as you see from the starting, it's showing I in 10, right? So that means 10 iterations will be done in this I. Okay, and down 1, step 2. So let's see what's the code over here, what's the output over here. Oh sorry, I forgot to change this for loop with steps. I need to do it. So here if you see, the for loop can iterate with a specified step. Here it counts down from 10 to 1 with a step of 2. Okay, so if you see it counting down from, so the initial value of I would be 1, and in 10 it's saying, that means, and step of 2. Okay, that means in every step the difference will be 2, and it's showing down 2. Down 2 means it will be in the decreasing order. Okay, from high to low it will go. Up to means from low to high it will go. It's sort of like this. Okay. Now let's go with the final type. I'm gonna say fun. This time we are gonna go with for loop with ranges and filters. Okay, both. So I'm gonna say for loop with ranges and filters. So I'm gonna say for num in 1 dot dot 20. Then I'm gonna say if num modulo sign 2 is equals to 0, println even number. Okay. So this is for loop with ranges and filters. Okay, so what does this mean? So I'm gonna go between num from 1 to 20, and those numbers will only print which divides by 2 and leaves a remainder as 0. Okay, which is an even number. Just to print the even number, this is the condition. Okay, make sure you copy this function and paste it over here in the main function. With the for loop, you can incorporate conditions within the loop. This example prints even numbers between 1 and 20. If you see this, between 1 and 20, it's printing all the even numbers. Okay. And there you have it. The for loop is a versatile tool for performing repetitive tasks in your Kotlin programs. Whether you are working with ranges, collections, or specific conditions, the for loop can handle it all. Practice using it, experiment with different scenarios, and enhance your programming skills. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin learners. Today we are exploring the while loop, a powerful iteration construct in Kotlin. This loop allows us to repeatedly execute a block of code as long as a specific condition is true. So let's dive into the world of while loops. So what I'm going to do is I'm going to create one class over here. Let's go to src main under Kotlin, create one class, Kotlin class of file. I'm going to name it as while. Okay, done. Now what I'm going to do over here is the first example we are going to take it is with the basic while loop. So what I'm going to do, I'm going to say fun. I'm going to create a function. I'm going to say basic while loop. Then what I'm going to do, I'm going to declare a variable of suppose count. Then I'm going to say while count less than 5. I'm going to say println count $count. Done. Now we need to increase the counter. So count plus plus. So count plus plus is more or less equal to count is equal to count plus 1. It's same as this. And this is the comment. So there are two types of comment actually. One is a single line comment and one is a multiple line comment. So you could also just suppose I just remove this thing, and if I want to comment this whole statement, so what I'm gonna do, and I'm gonna close it like this. So these are this. So this is basically a multiple line comment. Okay, I'm just gonna remove it for now. Once that is done, we need to execute this function. So just okay. So what I could do is uh, just sorry, let's go over here. Let's convert this class to fun main braces, and it's done. And let's execute this current file. Okay. So in this example, the while loop continues to execute the block of code as long as the count is less than 5. The count is incremented with each iteration. Let's see what's the output. The output should be 0, 1, 2, 3, 4. Great. Similar to for, we are using while in this. Okay. Now let's take a second example. So the second example is like infinite while loop with a break. Okay. So suppose fun infinite while loop now. Let's take a variable x, then let's do while. Suppose an infinite while loop we are putting over here, so the condition over here is true. Okay, that means the while loop will execute infinitely. Now I'm gonna say println value of x. Then what I'm gonna do, I'm gonna say x plus equals to 2. So what this statement means is x is equals to x plus 2. So this statement is equivalent to just the short form. It's just a short form. Okay, so x plus is equals to 2. That means we are incrementing in each iteration, we are incrementing the value of x by 2. And if x is suppose greater than 10, then I'm gonna call break. Okay, so what will happen, since the condition is true and the value of x is 1, I'm gonna print the value of x1 and I'm gonna execute this statement, that is x value is 1 and we are incrementing it by 2, then the x value is 3. The compiler will try to execute this condition, so 3 is greater than 10, that means it's a false statement. Then again the compiler will try to execute this statement, sort of like this. Okay, so let's see what's the output for this. So here we have an example of an infinite while loop. We use the break statement to exit the loop when a specific condition is met. In case the x value is greater than 10, then break is called and we get out of the while loop. It's sort of like this: 0, 1, 2, 0, 1, 2. Sorry, I need to copy and paste this thing. I need to execute this function. Okay, the value of x 1359579, and in the next expression after this execution of this code, the next expression value of x will be 11, which doesn't satisfy this condition, and break is executed. Okay, done. Now let's do while loop with user input this time. Okay, so I'm gonna say let's make a function of loop with user input. Let's create a scanner. Okay, so what is a scanner? Scanner is basically used not even in Kotlin but also in Java to take an input. Okay, take an input from the user. Scanner system dot string dot in. be like this, string dot in. Just press this thing, press option enter, press the first option. So if you see this library is basically imported, which is used for scanner class. Okay, and I see an error over here. What is, let's try to wrap this thing. So showing the expression cannot be a selector occur after a dot, too many character in a character iteration. Okay, I don't see any problem with this. So val scanner is equals to scanner. Okay, got it. So here it's system.string, system.in, done. Now what I'm gonna do is I'm gonna take the user input. So I'm gonna say var user input. Then I'm gonna say it should be a string, suppose. Okay, done. So by using this, I don't know why it's showing red over here, expecting an element, system dot in. Okay, make sure you have these signs over here in. Okay, so by using scanner, what happens is we will be able to write the input, and that input we are going to save it in user input. Okay, so these are the two variables. One is a constant, that is we have used val, and for the other we have used var. And then what I'm going to do, I'm going to say while, let's do an infinite loop. While true, I'm going to say print enter. Sorry, so if you see, I have not used println, but rather I'm using print. Okay, enter a word or exit to quit. Okay, then what I'm gonna do, this is the print statement that we are using. Then what we are gonna do, we are gonna take a user input is equals to scanner dot next line. So next line is basically used to take the input. Okay, now we are assigning the value, whatever value we are gonna put, we are assigning it in the user input. Once that is done, we are gonna check if user input dot to lowercase equals to exit. Okay, what I'm gonna do, I'm gonna call a break. So why I have used two lowercase, because suppose I have written the exit in capital letters, so it will take the value of whatever the value in user input and will convert it into lower cases, and then we'll match it with the string whether this matches with the exit or not. If it matches, then we are gonna break it. Else what we are gonna do, we are just gonna print it. Okay, so I'm gonna say println you entered user input. A simple line of codes, I think. Just copy this thing, and paste it over here and try to run this code. So in this example, we use a while loop to repeatedly prompt the user for input until they enter exit, demonstrating how loops can be used for interactive user interface. So if you see enter a word or exit to quit, so I'm going to say suppose Karthik, you entered Karthik, then again this is getting executed. So what is happening over here? So created a variable called scanner, then user input to fetch the whatever input we are putting. So in this case it's Karthik. So it's first printing this, first it's executing this, that is the true condition, then it's coming over, the compiler is coming over, it's printing the statement, then whatever we are writing over here, that is this thing Karthik, it's taking this input and try to check it with the this statement. So suppose Karthik I have printed, so it will convert all the characters to lower cases and will try to match up with this text. If doesn't it matches, then we are going to execute this statement. Now suppose if I want to press exit in capital letters, done. So while pressing exit, the value of user input will be exit in small letters over here, and then it will try to match it with this string. The condition is true, break is executed, we get out of the loop. That's it. Okay, now let's take a small example of a while loop with condition at the end. Okay, so what I'm going to do is I'm going to create one more function, loop with condition at end. I'm going to create a variable countdown is equals to 5, then I'm going to say while countdown is greater than 0, I'm going to say print ln countdown, then I'm going to say countdown minus minus. So it will basically reverse, it will print the value of countdown reversely. It will start from 5, 4, 3, 2, 1, sort of like this. So unlike the for loop, the while loop checks the condition at the beginning. If you want to check the condition at the end, you can use a do while loop as well, which we will cover in some another lecture. Okay, 4, 5, 3, 2, 1. And there you have it. The while loop is a fantastic tool for situations where you need to repeat a block of code based on a condition, whether you are counting, processing user input, or handling dynamic scenarios. The while loop is your go-to solution. Practice using it, experiment with different conditions, and enjoy the flexibility it brings to your Kotlin programs. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin enthusiast. Today we are diving into the do while loop, another essential iteration construct in Kotlin. This loop ensures that the block of code is executed at least once, regardless of the condition. Let's explore the do while loop together. What I'm going to do is I'm going to create one more file. I'm going to say file, then let's say do while. Now I'm going to say fun main. Once that is done, let's execute one block of code for do while. So it's a basic do while loop which we are going to do it. So I'm just going to say suppose function name is basic loop. Okay, now declare a variable count, then I'm going to say do print ln, I'm going to say count, then I'm going to say count over here, done, count plus plus while, now let's put the condition over here, less than 5. Okay, so what does this code mean? Just copy this thing and paste it over here so that we could execute it. Now we have initialized a variable with a value 0. Now for do, what happens is at least once the code will be executed. So first it will try to execute this and then it will try to check the condition. Okay, so sort of like this. In the while, first it checked the it was checking the condition, then it was executing the block of code under while. But for do while, it will first execute the code at least once. It will execute the code and then it will try to match up with the condition. If the condition is true, then it will try, the compiler will try to execute this code, then this line, then this line, sort of like this. Okay, so let's see what's the output. So in this example, the do while loop executes the block of code first and then checks the condition. As long as the count is less than 5, it continues to iterate. It's more or less similar to while loops only, so I'm not going to show much examples of it. All the things that we have done in while, we could do it in do while as well. Okay, so 0 1 2 3 4. So as soon as the count, so the value of the last iteration, for the last iteration the count value is 4 and then it's showing count plus plus, so that means count value is 5 now, and if it checks 5 is less than 5, which is a false statement, then it will come out of this do while loop. Okay, sort of like this. And that wraps up our explanation of the do while loop in Kotlin. It's a powerful construct that guarantees the execution of the block of code at least once, making it suitable for various scenarios. Whether you are interacting with users or implementing menu system, the do while loop adds flexibility to your Kotlin program. Practice using it, experiment with different conditions, and enhance your programming skills. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin learners. Today we are delving into the world of object-oriented programming in Kotlin. We will explore how to declare classes, create objects in this lecture. So let's get started. So classes and objects are fundamental concepts in object-oriented programming. Meanwhile, let's create a class, a file, a new project actually. New project, name it as Kotlin IntelliJ done, created. A class is a blueprint for creating objects, and objects are instance of a class. Let's see how this works in Kotlin. Okay, it's getting created. Done. Just remove this code. Also remove this one. Done. Now let's take an example. So what I'm gonna do, just go to src main Kotlin, and over here I'm gonna create a class. I'm gonna declare a class. Go to new, go to Kotlin class of file. Suppose the class name is person. Okay. Now each person has its name and age. So I'm gonna say var name. I'm gonna say it's a string, and initially it's nothing. Then again var age, it's an int. Initially it's 0. Okay. So in this example, we have declared a simple class called person with two properties, name and age. These properties define the characteristics of a person. Now in the second, let's create an object from a class. Okay. So this is a person class. Now we are going to create an object. So just come to main.kt file, and over here I'm going to say I'm going to create an object from the person class. So I'm going to say val person1 is equals to person. Okay. Similarly, second object I'm gonna create person2, and I'm gonna say person. Okay, now what I'm gonna do is I'm gonna set the values for the properties. So I'm gonna say the properties of person1. I'm gonna say person1 name is equals to John. Okay, and the person1 age would be sort of 25, suppose. Okay, now again person2 name is suppose Jane, and person2 age is suppose 30. Now let's print the information about these two people, right? So I'm gonna say println println uh, I'm gonna say curly braces, and then I'm gonna say person1 dot name is curly braces on person1 dot age years old. So it shall print something like this, that John is 25 years old, sort of like this. So whenever we are taking the value from another class, we need to implement this curly braces. We can't directly do it, right? So I just want to copy this thing, just change it over here person2, and sorry, I need to change it person1 over here, person2 person2 person1 person1. Correct. Let's run the code. So in the main function, we created two objects, person1 and person2, from the person class. We then set values for their properties and print information about them. This demonstrates the concept of so if you see, John is 25 years old and Jane is 30 years old, right? Great. So in the next lecture, we are gonna discuss about the constructors and all. So, and there you have it. We have covered the basics of declaring classes and creating objects. These concepts from the foundation of object-oriented programming, allowing us to model real-world entities and their behaviors. Practice creating your own classes and objects, experiment with different properties and methods, and explore the world of OOP in Kotlin. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin enthusiast. Today we are delving into constructors and initialization block in Kotlin. These features enhance the flexibility and initialization capabilities of our classes. Let's explore how to use constructors, initialization blocks, and object in your Kotlin program. So, first we are going to deal with primary constructors. Okay. So what are primary constructors? Just go to the person over here. Okay. In person class, if you see, I have declared two variables, but in suppose I want to pass it from here. So how to do it, right? So what I'm gonna do, what primary constructor means is I'm gonna say bracket over here. I'm gonna say val name string. Then I'm gonna say val age is there, which is an int. Okay. Now remove this two things. Now if you just come to main activity, red red is showing over here. That is an error. It's not valid is showing. So what you just do is, and over here you are seeing that this is red, right? So just cut this John, and you need to pass the parameter like this. Okay. Just remove this Jane 30 and remove this as well. It's just the same as we have done earlier, but only I'm passing the value like this. Okay. Now if we just try to run this, same output we are gonna get. Okay, so yeah, so in this example we have declared a class person with a primary constructor. The constructor parameters name and age and are also declared as properties. These concise syntax automatically initialize and assign values to the properties. Okay, now let's deal with init functions. What are init functions? So let's create a class. I just go new Kotlin class file. I'm gonna say suppose example clearly. Now what you have to do is I'm gonna say init. So whenever you are calling the object, right, this object, if you're calling, if suppose I'm calling example object in the main, then always this init function will be called automatically. So I'm gonna say suppose, let me explain by the help of the code. So I'm gonna say println, I'm gonna say initialization block 1. Okay, once that is done, come out of it. I'm gonna say val name string is equals to Kotlin. Then I'm gonna say just copy this thing, remove this, initialization block 2, just type this thing, done. And under this only I'm gonna say println name. Okay, so let's see what's the output for this, but before that let's make an object of it. So in the main function, just remove this code. Okay, so what I'm gonna do, I'm just gonna say example, remove this parameter, remove these things. So in this example, the example class has two initialization blocks. They execute when an object of the class is created. Initialization blocks are useful for setting up initial conditions or performing complex initializations. So if you see initialization 1, block 2, and the name Kotlin. If you just come to example, first this code is executed, then this, then the whole of this. Okay, so sort of this is the function of init. Now let's combine all the constructors. Now just combine the init and constructors, and let's do an example on this. Okay, so just come over here, create a class called Kotlin, and I'm gonna say student. So on the student class, small bracket, under small brackets, I'm gonna say val name string val age, it's an int, and I'm gonna initialize it to 18. So previously we were not initializing it, right? If you just come to person, here we were not initializing it, rather we were taking the values from the main activity. But what I have done by default, if I want to put a default value, so I could do it like this. Okay, so once that is done, what I'm gonna do, I'm gonna say I'm gonna use an init, and then I'm gonna say println student initialized name comma age. Now I'm gonna create a function as well. So I'm gonna say fun display info println student information name comma age. I think we are done with this. Now let's come to the main activity over here, the main function. Now let's create an object of the student class using the primary constructor. So I'm gonna say val student1 is equals to student Alice comma 21, suppose. So if you see, it's not mandatory. So if I could remove the age, it's not showing any error. Why? Because if you see, come to student, just gonna remove these two. So if you just come to student, I have initialized it as 18. So it's not necessary to add age, but if you want to override, I could easily override it. But as of now, I'm not overriding. No issues on that. Okay. So once that is done, let's create another object of student class with the default age parameter this time. Okay, so I'm just gonna do it 21, just copy this thing, paste it, student2, and this time we're gonna use the default one, change it to done. Okay, now let's display the information about the students. So I'm gonna say student1 dot display info. What is this display info? If you just press command and hover over it, and if you just click it, so this is the function, okay, which will print the student information, name, age, and everything, right? And student2, I'm gonna say display info like this. Okay, now what should happen, right? What should happen from this? So if you see, student1 display info is there, right? So as soon as we initialize this one, so it should print the init function first. So it should print student initialize name as Alice and age will be 21, right? And same will be and then again, when we have initialized the student2, the details of student2 will be name will be Karthik and age will be by default, that is 18 over here, right? It's sort of like this. So let's see what's the output for this thing. So the age parameter is the student class constructor now has a default value of 18. When creating student1, we provide an explicit age value. So if you see, first two initializations have been done. The first one initialization is student1. So we have Alice and age is 21, which we have put over here. Then the second initialization was student2. So the name is Karthik and the by default age is 18, which is all this. Okay. Now once we call this function, that is student.display, so student.display, we are getting this information from the Alice one, and the second one, student2, information is Karthik and age 18. It's sort of like this. Okay. Alright then, and there you have it. Constructors, initialization blocks, and using object in Kotlin provide a robust foundation for building object-oriented programs. Whether you are creating instances of class with primary or secondary constructor or leveraging initialization blocks for additional setup, these features enhance the flexibility and expressiveness of your Kotlin code. Practice using them, experiment with different scenarios, and enjoy the benefit of object-oriented programming in Kotlin. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin learners. In today's lesson, we are delving into the powerful concept of inheritance. Inheritance is a cornerstone of OOPS, allowing us to create classes that build up the characteristic of existing ones. Let's explore how inheritance works in Kotlin with some practical examples. So what I'm gonna do is I'm gonna create a class. Let's remove this class, student and all. Okay. In Kotlin, I'm gonna say new. I'm gonna go in the package. I'm gonna say inheritance. Under this package, I'm gonna create few classes now. So just go to new, then Kotlin. I'm gonna name this file as animal. Create this class. Done. Now this animal class, what I'm gonna do, I'm gonna pass one parameter over here. Suppose val name. It's a string. Okay. Then I'm gonna pass a method in this. So I'm gonna say fun speak println name makes a sound. Great. So once this is done, I think everything is set. Now I'm gonna create one more class of the dog class. So this is the parent class, and now I'm gonna create a dog class. So just go to new Kotlin class, then say it as dog, create a class. Now in the dog class, that is the derived class, we are gonna pass the parameter that is name. And we are gonna inherit it. So how to inherit it? So I'm gonna say animal and then pass the name. So what I'm doing, if we just come to animal, so we need to pass one parameter that is the name right over here, so that we could inherit it. So I'll just write animal and the name parameter, that it is taking this one. Okay, this name I have passed over here. Now so showing red, no issues. So now what I'm gonna do is I'm gonna create one more method in this. I'm gonna say suppose wag tail. So what are the properties of a dog? So a dog could have a tail, and right. So what I'm going to say is on wag tail and println name wags tail. Done. Once that is done, I think everything is set. Here is showing an error. Let's see what's the error. Make animal open. Okay, yes, I forgot to make open over here so that it could be inherited. Okay, make sure the parent class over here, you write open over here. Okay, now if you see, this is the parent class, that animal is the parent class and dog is the child class. So you need to make sure whatever functionality we have in animal are basically present in dog. Okay, so all animal speaks, right? So properties like speak, then how the animal respirates, how the animal locomote, these things we could basically put it over here. And not all properties. So dogs basically can't swim, right? Underwater they can't swim, but I think dolphins and other aquatic animals can swim, so we can't add those functions over here. Only those functions which basically the dog possesses, we are gonna add it over here, a sort of example. Now what I'm gonna do, just go to main, just remove this code from the previous lecture. Now I'm gonna say val my dog. I'm gonna create an object of dog, and I'm gonna pass the dog name, that is buddy. Okay, make sure you click on this option and done, so that the package is basically imported. Now once that is done, I'm gonna say my dog dot speak. Okay, now this is inherited from the animal class, this one. If you just go to dog, if you see, there is no method called speak, but rather it's present in animal, which is basically derived it directly. So we are deriving it directly. Okay. Now I could say my dog dot wagtail. So the wagtail method is basically present in dog, right? This thing, but the animal, that is the sorry, over here speak method is basically because the animal class is inherited in dog, we could directly access whatever the methods or attributes we have in animal, we could directly access like this. Okay, now let's run the file and let's see what happens, what's the output. So in this example we have a base class, that is animal, and a derived class dog. The main function creates an instance of dog called myDog and demonstrates calling inherited and specific methods. So if you see, buddy makes a sound, buddy wags tail. Great. Now let's work on an override. So this was an simple example of inheritance. Now let's do some coding on overriding methods in derived class. Okay. So what I'm gonna do is go to the animal class. Right, just go to the animal class, and I think I don't have to make any changes over here. Just go to dog classes. Over here I'm gonna say override fun speak println name bark. Okay. Now if you see, just go to animal, make sure it's open so that this could also be inherited. So if you see, there is a function called speak in animal as well as in dog. We have now written a function speak, right? So suppose if in the main, if I call this method, so which method will be printed, which method will be executed? So the dog method, the method that is present in the dog, is basically executed. So if you see, animal, in animal it says name makes a sound, and in dog it says name bar. So let's see which method is basically getting executed. Let's run the app, run the program, sorry. Okay, buddy box. So buddy box is basically in the dog method. In the dog class we have this buddy box. So this method is getting executed. So this is basically method overriding method. Okay, now let's work on one more example, that is a superclass initialization with main function. So suppose I just suppose let's create one more package over here, new package name, let's give it engine. Suppose let's take an engine. Okay, now create a class over here. The class name is vehicle. Sorry. Done. Now make sure the vehicle class is open because we are gonna inherit this. Then I'm gonna pass attribute brand string. Done. Once that is done, now let's make an open function. I'm gonna override this function. I'm gonna say println starting the brand vehicle. I think it's done. Now let's create one more class. Go to new Kotlin. I'm gonna say this time the class name is car. Okay, Now let's pass few attributes over here. So I'm gonna say brand string model string vehicle brand. So if you see, I'm just gonna remove the animal and dog class as of now. So if you see, this is the parent class, that is the vehicle, and we are basically passing an attribute called brand. Okay, we just come to car, we are passing the attribute brand over here, right? That is this one, but there is one more attribute in the car, that is model, and which we are not passing. Okay, so let's see where this model could be used. So I'm saying override fun start, and then I'm gonna say print ln car is ready to go. Okay, so what we have done over here is that this is super.start. Okay, that means we are inheriting this method. Okay, so this will be first printed and then this will be printed. If suppose I want to print both, okay, so what I'm doing, I am first printing this one, which is executed by this code, that is super.start. Okay, and then we are basically then basically this method is getting printed. Okay, so if okay, so let's first run the code and let's see what's the output. I'm gonna say val my car is equals to car Toyota, then Camry. Spaces option enter, done. So if you just come to car, the brand is Toyota and the model is Camry. Okay, come to main. Over here I'm gonna say my car dot start. Let's run the code and let's see what happens. So in this example, the main function demonstrates initializing a car object and calling the overridden start method, which in turn calls the start method of the base class, that is the parent class, using super.start. If you see the output, starting the Toyota vehicle, so if you just come to vehicle, it is executing this line, starting the Toyota vehicle. If we just come to car, we have used super.start. So what's doing is, whatever the parent class is, it's checking whatever the method we have in the parent class. If suppose the method is start, that is this method, it's basically this line is used to execute that method, right? And then we are executing this. So if we just remove this thing and then I try to run the app again, only car is ready to go will be printed. Okay, great. So that concludes our exploration of inheritance in Kotlin. We have seen how it allows us to build upon existing classes, providing a foundation for creating more versatile and organized code. Now go ahead, experiment with inheritance in your Kotlin projects and unlock the future potential of object-oriented programming. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin enthusiasts, today we are delving into the fascinating world of polymorphism and method overloading. These concepts allow us to create more flexible and versatile code in Kotlin. Let's explore how they work together in action. So in the previous lecture, we have already dealt with method overriding, which is one of the part of polymorphism itself. Now we are gonna deal with method overloading. So polymorphism allows a single interface to represent different types, or in the case of Kotlin, for a single function to take on different forms. Method overloading is a form of polymorphism that allows a class to have multiple methods with the same name but different parameters. Let me show you how. So let's create a package over here. Name it as polymorphism. Okay. Now let's create a class. Name it as math operations. Done. Now what I'm gonna do, I'm gonna create functions. Okay, so I'm gonna say fun, I'm gonna say add a int comma b int, then I'm gonna return it as int. I'm gonna return a plus b. Done. I think everything is done. Now just copy this thing, paste it. Now I'm gonna take it as, do it as double, double, make everything double over here. Done. Now again copy it. Now this time I'm gonna use string, copy this, paste string, done. Now just come to main activity. Just gonna remove this vehicle and car from the previous lecture. Over here, remove the previous codes. I'm gonna say, suppose val math ops is equals to, I'm creating a new object of math operations which we have just created. Okay, once that is done, I'm gonna say, suppose val result int is equals to math result in is equals to math op dot add and pass the integer. So if you see over here, I am passing integers, right? And if you just go to command enter, if you see over here, there are three functions with the same name, right? But the parameters are different, the parameter types are different. Here we have an integer type, here we have double and string, right? So the compiler will automatically detect what type of a parameter I'm passing. If I'm passing an integer, it will try to execute this function. If I'm passing a double, it will try to execute this function. So sort of like this. Okay, I'm just gonna copy this thing, paste it, result double 3.5, 5.6 for the double, and it's the result string, suppose Karthik Kumar. Oh, done. Now let's print this value and let's see what happens. I'm gonna say result in bracket int result int. After the space, paste result double result string result double, and over here a result string. Done. Now let's try to run this code. So in this example, we have a class method operations with overloaded add method. The main function showcases polymorphism, where the same method name add is used with different parameter types. Okay. If you see, It's done. Right, it's working fine. So here we have a base, and there you have it. We have explored the powerful concept of polymorphism and method overloading in Kotlin. These features allow us to create more adaptable and expressive code, making our program more robust and maintainable. Now go ahead, experiment with polymorphism and method overloading in your Kotlin project and witness the flexibility they bring to your code. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin learners, today we are delving into the concept of interface. Interface provide a way to define a contract for classes, allowing them to share common behavior while still having their unique implementations. Let's explore the world of interfaces in Kotlin. So, an interface in Kotlin is a collection of abstract methods. Classes can implement one or more interface, inheriting the abstract method defined in those interfaces. Let's take an example and let's explain. Let's try to understand. So what I'm gonna do, I'm gonna create a package. Just go to new package and I'm gonna say interface. Create that package. Under that package, I'm gonna create a new. Then I'm gonna say there is no. Okay. Just create a Kotlin file. Select interface, and over here I'm gonna say shape. Done. So in this interface, what I'm gonna do is I'm gonna create a method. I'm gonna name a method draw. Okay. Now under this interface, what I'm gonna do, I'm gonna create a new class now, Kotlin class, and I'm gonna name it as circle, suppose. And now I'm gonna create a class implementing the interface. Okay, so what I'm gonna do, I'm gonna write shape like this. So what this class is doing, it is basically interfacing the shape, this one. Okay, now if you see a red bulb is shown over here, just click on that and you will see implement method. Just click on that. It will show this only one method is there, that is the method inside the shape. Just select OK. Here we go, and override method is done. So what is the function of interface? So whatever method you are writing over here, okay, I'm just going to remove this. Whatever method you are writing over here, and when you are implementing it in any class, automatically you have to implement those methods as well. Okay, so here we have a draw method, and in the shape we have a draw method. You need to implement those methods wherever you are basically inheriting that interface. Now suppose I just want to print dr drawing a circle. Done. Now just come to main, and what I'm gonna do, I'm gonna create a variable of circle, sorry, object of circle. Done. Now I'm gonna say circle dot draw. Okay, so what does this mean? I have created an object of circle, that is this class, and this class contains a method called draw, and I'm calling that draw. Okay. In this example, we have an interface shape with an abstract method draw. The circle class implements this interface and provides its unique implementation of the draw method. The main function demonstrates creating a circle object and calling its draw method. So if you see, drawing a circle. So let's move on to the next example. So in this example, we are going to try with multiple interfaces and default implementations. So what I want is, we have a shapes class. I'm going to create one more interface. Let's go to new Kotlin, select interface. Over here I'm going to say fillable. Okay, in this fillable, suppose two functions are there. One is fill and second function is like is filled, the function name is filled, and the return type of this function is boolean. I'm gonna say return true. By default I need to put something. I'm saying return true. Okay, now let's implement multiple interfaces in a class. Okay, so I'm gonna create a class now in this under interface only. Let's go to new Kotlin class file. Class, the name of the class must be colored circle, suppose. Now I'm gonna take those interfaces. I'm gonna say shape, implement those interfaces. I'm gonna shape and fillable. So the shape is this one and fillable is this one. Once that is done, red color is basically shown. Just press on that well. Implement methods. Okay, two methods are there. From shape it's one, and from fillable it's fill. Done. Now override. So what I'm gonna do is under draw, I'm gonna say println drawing a colored circle, and under fill I'm gonna say println drawing a colored fill, not drawing, I think filling a colored circle would be nice. Filling, let's try filling the circle with color. Okay, now if you see, if you just go to fillable over here, we have two methods over here, that is fill and is fillable, and in shape we have only draw. Okay, all right, just go to main activity, sorry, main function, main class. I'm gonna create object val colored circle, colored circle. Done. Now using methods from multiple interfaces, I'm gonna say colored circle dot draw. Just copy this thing, paste it. Dot draw. Why it's showing red? COLO colored circle. Okay. Now then I'm gonna say colored circle dot fill. So these methods are basically the draw and fill methods are this one, fill and draw. Okay. And using a default method from fillable interface, I'm gonna say val is filled is equals to colored circle dot is filled, and then I'm gonna print the value, that is println is filled So what does these lines meant? So if you see, just go to colored circle. We are basically implementing this interface that is fillable. Now if you just go to fillable, you see this is a default method, right? Which we could access. So if I'm calling this method, that is field, I'm calling this method is field, and it's returning true, right? So is field value is true, and it will print true over here, sort of like this. Okay, so we can use methods. We could basically create methods as well. By default methods also we can write down logics as well in this, not a big deal. So in this example, we have two interfaces, shape and fillable. The colored circle class implements both the interfaces, providing implementations for the abstract methods. The main function showcases using a method from multiple interfaces and utilizing a default method from the fillable interface. So if you see, we have the desirable output. And that concludes our journey into the world of interfaces in Kotlin. Interfaces are a powerful tool for defining contracts and promoting code consistency across different classes. Go ahead, experiment with interfaces in your Kotlin projects and unlock the potential of building flexible and maintainable code. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin learners. Today we are diving into the concept of data classes. Data classes in Kotlin provides a concise way to create classes for holding data, eliminating boilerplate code and enhancing readability. Let's explore the simplicity and power of data classes in Kotlin. Meanwhile, what I'm going to do is just create one package of data class. Done. So data classes in Kotlin are special classes specially designed for storing and maintaining data. They automatically generate useful methods like toString, equals, hash code, and more based on the properties declared in the class. Let's take an example. So basic data class example we are gonna go with. So I'm just gonna create a Kotlin class. Name of the class would be just click on data class over here and set as person suppose. I'm gonna remove all these things from the previous lecture. Okay, now what I'm gonna do, I'm gonna two attributes I'm gonna take. One is the name, comma, the other is the age. Done. Now what I'm gonna do, I'm gonna say fun main. Okay, what I'm gonna do, not here, I'm gonna do it over here only. Now I'm gonna create an instance of the data class. So I'm gonna say val person, first is the name, so I'm gonna say Alice suppose, 25 each. Then I'm gonna access the properties, so I'm gonna say println curly braces person dot name. So this is how we could access. Then the age. Done. Now, so we have access the properties. Now suppose I want to use toString method in this. So how to do it? So I could simply like println person details person details, then I'm just gonna say $person. That's it. Let's see what's the output. So this is basically the toString method. Okay, so in this example we have a data class person with properties name and age. The main function demonstrates creating an instance of the data class, accessing its properties and automatically using the toString method for converting and printing. Okay, the output, and this is the person detail output. Great. Now let's remove this, and now in the second example we are gonna copy and destruction in data classes we are gonna do. So what I'm gonna do is I'm gonna create a new data class. Suppose book is the data class. Over here I'm gonna say val title string comma val author string comma val year int done. Once this is done, just come to main. Now I'm gonna create an instance of a data class. I'm gonna say val book is equals to book. I'm gonna say Kotlin in action. Just press this option, enter. Then I'm gonna say geometry Jamrov 2017 done. Now we are gonna copy the data class. So how to do it? So I'm gonna say val updated book dot copy. What attribute I need to copy? I'm suppose I need to copy year, and what shall be the updated version? I'm gonna say 2022 suppose. So this is how we are basically copying. So 2017 was saved in the year attribute. Now 22 will be saved. Now suppose I want to now the action that I'm going to do is the destructing declaration. So what I'm going to do is I'm going to say val title, author and year. I'm gonna equal to as update book. Okay, so only the year will be updated and the rest will remain the same over here. Okay, in this file. So suppose I'm gonna take an output of this. So what will happen is I'm gonna say println original book then I'm gonna say updated book, then suppose the original book will print all the values, that is the original values, then the updated book is the updated value, that is this thing will be changed. Okay, now I'm saying destructing, so I'm gonna say suppose println, I'm gonna say during title comma author comma year. Okay, so these are basically the attributes which are basically similar to this only. Let's run and let's see what's the output. Okay, so I'm getting book, then the title, Kotlin action, author and 2017. Okay, and then the updated book is all the things are same, just this is basically changed, and here we go, title, all the things are same as to the updated book. Great. So in this example we have a data class book with properties title, author and year. The main function demonstrates copying the data class to create an updated version and using destructing declaration to extract individual properties. And there you have it. Data classes in Kotlin provides a very powerful way to represent and manipulate data in your program. With automatically generated methods, they reduce boilerplate code and enhance code readability. Now go ahead, leverage data classes in your Kotlin projects and experience the efficiency they bring to your data management. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin enthusiasts. Today we are exploring the automatic generation of toString equals and hash code method in Kotlin data classes. These features make our code cleaner and more efficient. Let's dive into the simplicity and power of automatic method generation in Kotlin data classes. So Kotlin data classes comes with built-in functionality for automatically generating essential methods like toString, equals, and hash code. This makes data classes not only concise but also highly efficient for common operations. So let's take an example. What I'm going to do, I'm going to create a new basic data class under this data classes only. So what I'm going to do, I'm going to go to new, create a class called it as point, and make sure it's data class. Now pass few attributes. So I'm going to say val x, that should be int, and val y, that must also be an int. Done. Okay, now come to main. Over here, just remove the code from the previous lectures. Now I'm going to create an instance of the data class. I'm going to say val point 1 is equals to point, and pass the x and y coordinates, that is suppose 3 and 5 I'm passing. So this is the point 1. Similarly, in a two-dimensional plane, I'm going to pass point 2 as well. Change the coordinates to 3 and 5. Let's take 3 and 5. No issues on that, so that I could show you an example. Now, using automatically generated toString, equals, and hash code methods, we are going to do it. So I'm going to say println points point 1, then I'm going to say point 1. So this is true toString method basically. Okay, here we are, this is actually the toString method. Just change it to point to string. Done. Now we are gonna use equality check using equals. So I'm gonna say println are points equal, question mark. Then I'm gonna do it something like this. I'm gonna say point 1 is equal to point 2. So this is basically used for, this is basically equal method. Okay, this is the toString method. Okay, and hash code generation is the next. So println, I'm gonna say suppose hash code of point 1, point 1 dot hash code. Done. And this is basically hash code 1. Okay, hash code, or it's equals, make sure it's s. Okay, just copy this thing, paste it over hash code for point 2. Done. I think we are set to go now. Just run the file and let's see what happens. So in this example, we have a basic data class point with properties x and y. The main function demonstrates creating instance of data class and utilizing the automatically generated toString, equals, and hash code methods. Okay, so here we go. It is a toString method. Okay, and this is our points equal, it's returning true. Okay, because we are checking the condition, that is equal sign. Then hash code, it's returning the hash code of this basically. Okay, great, and there you have it. Kotlin's automatic generation of toString equal and hash code method in data classes simplifies our code and improves its efficiency. Now you work with data classes, appreciate the convenience these features provide, making your code more expressive and readable. Go ahead, incorporate data classes in your Kotlin projects and enjoy the benefit of automatic method generation. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin learners, today we are delving into the powerful concept of extension functions. Kotlin allows us to extend existing classes with new functionality without modifying their source code. Let's explore the versatility and convenience that extension functions bring to Kotlin. So what I'm going to do is, let's create a new package over here. Name it as extension functions. Done. Now, so extension functions in Kotlin enable us to argument the functionality of existing classes by adding new methods. These functions make our code more modular and readable without modifying the original classes. Let's take a basic example, a basic extension function example. What I'm going to do is I'm going to create a new Kotlin file over here. I'm going to create a class, name it as dog for now. Okay. What I'm going to do is I'm going to remove these curly braces and I'm just going to pass a parameter that is val name and string st string. Oh, so if you see, I have not added any sort of a method under this. Okay, there is no function in the doc. So what I could do is just come to main, just remove the classes from the previous lecture. Okay, now what I could do is I could just remove the code from the previous lecture, and over here I could say fun. I could create a function that is suppose dog dot bark and use a print statement saying that name says woof. So what I've done over here, so if you just go to the dog class, there is no function, right? But I could create a method of that function. So this is called the extension function. This is basically an extension function. If you don't want to create a function inside that class, you can create anywhere by using the name of the class dot the name of the function, and then you can use the parameter also that class contains. So the parameter that class contains the name, I could use that name over here, right? And if I just try to run this, so this code you could do it anywhere. You could either just, if I suppose I want to cut this, and I could do it over here also, it's not an issue. Okay, you could do it in any file. Okay, as of now I'm just doing it over here. So I'm going to create the instance of the existing class. So I'm going to say val my dog is equals to dog, and then suppose buddy. Now I'm going to use the extension function, so I'm going to say my dog dot bark. So this is the function which I could use, as simple as that. So this is basically extension function functionality. I'm just going to run the code. So in this example, we have an existing class dog with a property called as name. The main function demonstrates the creation of dog instance and the usage of extension function bark, which is added to the main class. Okay, buddy says oof. Great. So buddy is this one. So it's taking the name over here and calling the extension class. I could basically use this name, and that's the output over here. Great. Let's go with some other example, some additional parameters we are going to use. Okay, so what I'm going to do is just come to extension function, create a new class. make sure it's class. Class name is suppose circle. Okay, just remove these parameters. What I'm gonna do, I'm gonna say val radius 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 double. Done. Now I'm gonna use an extension class with additional parameters. I could use it over here only. Let's use it over here. No issues. So I'm gonna say fun circle dot calculate area and I'm gonna return a double. Then I'm gonna just return it saying as math.py. So this is actually the pi value that I'm gonna get. I'm gonna multiply this with radius into radius. Done. I think we are good to go. So what I'm gonna do over here, just remove these functions. I don't need over here. Now what I'm gonna do is in the main, let's create an instance of the existing class. I'm gonna say val my circle is equals to circle. Just pass a double over here, double value. Let's see, it's double only. That's double. So why this error is getting shown? Import class circle. Yep. Extension function dot. Okay. Now what I'm gonna do is using the extension function with additional parameters, I'm gonna say val area is equals to my circle dot calculate area. Okay, and I'm gonna print it. So I'm gonna say println area of the circle area square units. So what I've done, extension function, this is basically called because if you just come to the circle, this is under this class, right? So I need to call this one over here, extension function. That's the package over here. Okay, that's the package name. So if I would have used this area calculator function over here, then this won't be required, but that is done by the ID by itself, so it's not an issue. Okay, we'll get the area and we are showing the area over here. Simple thing, not much an issue. We have already done this. So in this example, we have an existing class circle with a property radius. The main function showcases the usage of extension function calculate area method, which calculates the area of the circle by adding an additional parameter. Here we go, the output. So and that wraps up our exploration of extension functions in Kotlin. These functions provide a powerful way to enhance the functionality of existing classes without modifying the source code. Now go ahead, experiment with extension functions in your Kotlin project and witness the flexibility and readability they bring to your code. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin learners, today we are delving into the fundamental concepts of declaring and invoking functions in Kotlin. Functions allow us to encapsulate and reuse code, promoting modularity and readability. Let's explore the syntax and usage of functions in Kotlin. So what I'm going to do is I'm going to create a new project for this. I'm just going to go new, go to project. I'm going to say functions and lambda So functions in Kotlin are declared using the fun keyword. they can have parameters, a return type, and can be evoked to execute a set of instructions. Let's see how we declare and invoke functions in Kotlin. Just going to remove the by default code over here. Now let's go to src main Kotlin. Over here, create a package, name it as declaring and invoking fun. Under this, let's create a so let's do it in main only. No issues. So what I'm gonna do is over here, I'm gonna create a function. I'm gonna say fun greet name string. I'm gonna say println hello name. So this is called function declaration. This whole thing is called function declaration. You are basically stating the function, what all parameters it will have, what all functions it will have, what is the name of the function. So this comes under function declaration. Okay, now let's invoke the function. So how to invoke the function? I'm going to say greet name of the function, then pass the parameter, suppose Kotlin learners. Okay, so this is how we invoke the function. So this is invoking, this is declaring a function. Okay, let's run the code and see what happens. So in this example, we declare a simple function greet that takes a name parameter. The main function showcases invoking this function with the argument Kotlin learners. Here we go. Great. Now let's go with another example in which we will have a return type this time. Okay. So what I'm gonna do, let's remove this code. Over here I'm gonna say fun calculate sum. Suppose I'm gonna calculate a sum. A is an integer and I'm gonna pass b, which is also an integer, and the return type would be int, and I'm gonna say return a plus b. Okay, so this is the return type. This will showcase us what is the data type. Okay, and if we are doing this, then we have to include return over here. Okay, so this function will basically return a value to us. So this is basically declaring a function, and now what I'm gonna do, we are gonna invoke the function and get the results. I'm gonna say val result calculate sum, suppose 5 and 7 I'm putting, and then I'm gonna print it. Okay, so as soon as we call this function, we have to pass two parameters, that is the a and the b, and it will return an integer which we are gonna assign it to the result, and we are gonna print that result. Here we declare a function calculate sum that takes two parameters and returns their sum. The main function invokes this function and captures the result, printing the sum. Great, sum is true. Now let's take one more example in which a default parameter values we are going to take. Okay, so what I'm going to do, I'm just going to remove these things. Then so let's create a function with default parameter value. I'm going to say suppose fun greet person. I'm going to pass a name with a string. Again, one more parameter, greeting is equals to, this time I'm gonna pass a value to it. Okay, so if you see, there are two parameters. The first parameter is called name and the second is greeting, but in the second one I have passed a by default value to it. Okay, and then what I'm gonna do, I'm gonna go with a println statement. I'm gonna say greeting comma name. Done. Just call this function. Let's invoke this function. I'm just gonna say greet person, pass the parameter Alice, and then let's create a custom greeting. So what I'm gonna do, I'm gonna say greet person, this time suppose Bob comma hi. So what's happening over here? So there are two options for me. Either I could pass a parameter or either I don't pass a second parameter. Okay, because by default I have already provided one, so the compiler recognizes this and do not show error in the first function. Okay, in this function it will not show an error because compiler knows that we have a by default value over here. If not provided, it's gonna take this. If provided, as in the case of this, sort of like this. Let's see what's the output. In this example, the greet person function has a default parameter value for greeting. The main function showcases invoking this function with and without providing the optional parameter. Great. Now let's take one more example in which we're gonna go with function expression, a single expression function we are gonna go with. So how to do it? Let's remove this thing. I'm gonna say fun. I'm gonna suppose do a multiplication, multiply, I'm gonna take x and y, and then I'm gonna return a value. I'm gonna say int is equals to x into y. Okay, so this is a single expression function in which these are the two parameters that have been passed and this is the return value. Okay, so instead of so the alternative of this was I would have done sort of like this, so return x into y, but instead of that what I have done is just a normal function, a single line function. Okay, now let's invoke this. I'm going to say val result multiply 4 and 6, suppose normal value you want to take, and then I'm going to say println product result. Here we declare a function multiply using a single expression, eliminating the need of explicit return. The main function invokes this function and prints the product. Great, we got the output. And that concludes our exploration of declaring and invoking function in Kotlin. Functions are the building blocks of your Kotlin programs, allowing you to encapsulate logic and promote code reuse. Now go ahead, experiment with declaring and invoking functions in your Kotlin projects and witness the power of modular and readable code. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin learners, today we are delving into the concept of local functions. Local functions in Kotlin allow us to define functions within the scope of other functions. This promotes modularity and encapsulation, making your code more organized and readable. Let's explore the power of local functions in Kotlin. So what I'm going to do is just create a new package, name it as local functions. Under this package, okay, we need to create a function, so I don't think we need to create a package. Okay, so what I'm gonna do in the main, just remove the code. from the previous lectures. Over here I'm going to say let's create an enclosing function. So what is an enclosing function? I'm going to explain it. So let's create a normal function as of now. Calculate grade. Now the return type, what I'm going to do is the return type is string. Okay, great. So this is a normal function which we have already learned about. Now we are going to create a local function. So local function is a function within a function. Okay, so I'm going to say fun. It's a normal function which is basically declared inside a function. Determine grade. Over here I'm gonna say return type would be string for this function. Now what I'm gonna do, I'm gonna say return when score in 90 to 100, I'm gonna return A. Just copy this thing, paste it, paste it, paste it. Now over here just change it to 80, and these two dots write it as until. Just copy this until, remove this dot, space over here, change it to 70, change it to, now change it to 60, then over here 90, it will be 80 and 70, take it as B, C and D. Once that is done, I'm gonna say else F. Now what I'm gonna do is I'm gonna return this time. Okay, so this is the function inside which after else, okay, so this function is basically returning this value in this whole thing, whatever the value of this will be, it will return that. Okay, great. And once this is evaluated, over here I'm gonna say return just call this function return, just copy this thing, return grade, done. So what is happening, whatever the value, so I'm returning a string over here, I'm returning a string and I'm passing this function over here, that is this function. So whatever value I will get into by this string, it will just copy that value over here and will return the string. And what I'm going to do in the main function is I'm going to invoke that enclosing function. So I'm going to say val result is equals to calculate grade. Let's take 85, print ln result. Let's see what's the output. So in this example, the calculate grade function has a local function determine grade that calculates the grade based on the score. The main function showcases invoking the enclosing function, which in turn calls the group function to determine the grade B, that is this. So it's falling under this lab. Great. Let's take one more example. In this, we are going to take the local function with parameters this time. Okay. So I'm going to remove this whole thing. Just remove it. I'm going to create an enclosing function. I'm going to say fun print details name string age int. Now I'm gonna create a local function with parameter. I'm gonna say fun display message greeting, and it will be string. I'm gonna print it, println greeting, then name, you are here, or okay. So what in this, what we have done is the local function have one parameter, and the main function, the enclosing function, also had two parameters, and the local function can use all the parameters, that is from the enclosing function also and from its function as well. Okay, so this is one example. So what I'm going to do is I'm just gonna say display message hello. Okay, now in the main function, let's invoke it. So I'm gonna say print detail alice comma 25. Alice comma 25. Great, let's see what's the output. So this message will be printed, that is the local function will get printed, that is this should be printed. So as the print detail function has a local function display message that takes a greeting parameter. The main function showcases invoking the enclosing function, which in turn calls the local function with a greeting message. And here's the output. Great. And that wraps up our exploration of local functions in Kotlin. These functions enhance modularity and encapsulation by allowing us to define functions within the scope of other functions. Now go ahead, experiment with local functions in your Kotlin projects and witness the benefits of more organized and readable code. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin enthusiasts. Today we are exploring the powerful concept of passing functions as parameters. In Kotlin, functions are first-class citizens, which means we can treat them as value and pass them as arguments to other functions. This flexibility enables us to write more modular and reusable code. Let's dive into the world of passing functions as parameters in Kotlin. Let's take an example. So what I'm going to do is I'm going to remove the code from the previous lecture. Over here I'm going to create a function execute operation let's take one parameter as value, then the type will be int. Now what I'm gonna do is I need to create a passing function over here. So I'm gonna say let's create one more attribute name as operation, and this time int, type will be int, and the return type of this function will be int, and then I'm gonna return operation value. Oh, so what is the value, what is the meaning of this? I'm gonna tell you soon. And before that, what I'm gonna do is I'm gonna take some example functions to pass as parameters. So I'm gonna say fun. I'm gonna explain each and everything as to what we are doing over here. I'm just gonna first write the code. So over here I'm creating a square function of as I'm taking an input name as x and the return type is int, and let's create one more function of double return x into 2. Once that is done, I'm gonna pass functions as parameters. So just come to main. I'm gonna say val result square is equals to execute operation. Let's take an example 5 comma square. So what does this mean? So what I'm doing is execute operation is a function, right? And I need to pass a value that is of type int, that is I passed 5 over here, and this thing is a function parameter. So I'm passing a function that is square over here, right? So what is this? It's a square, right? So I need to pass by adding these two symbols and then the square name of the function, so that the compiler knows that this is basically a function. Otherwise it will not determine, it will show that this is not a value, right? This is like just a square. But if I use these two symbols, and the compiler will get to know, okay, we are passing a function, so it will search in function. So sort of like this. Now what I'm gonna do is just copy this thing, change it to result double, and change the square to double. Okay, now I'm gonna print it. Result square double result double. The compiler will execute the code. So the compiler will first try to execute this one. So it will see, okay, execute operation is there, value is 5, and we are passing a functional parameter over. Okay. Now the compiler will try to execute this code, where this line will be executed first. So it will see, okay, operation is there and value is there. So what is the operation over here? The operation is this square function, and the value parameter is value over here. So the compiler will try to execute this square. It will return whatever the value is generated over here. Okay, it will assign the value over here, and it will return whatever the value over here. Suppose the value is 9, it will return and will copy that value to result square. It's sort of like this. First it will execute this, then first it will execute this, then this, and then it will assign the value over here, and then we can print it, sort of like this. So in this example, the execute operation function takes another function as a parameter. The main function showcases passing two different functions, square and double, as arguments to execute operation. Great, it's working. And that concludes our exploration of passing function as parameter in Kotlin. Leveraging high order functions, we can write more modular and reusable code by passing functions as arguments. Now go ahead, experiment with passing functions in your Kotlin projects and unlock the potential for creating versatile and expressive code. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin learners. Today we are exploring one of the fundamental and versatile data structure in Kotlin, list. Lists provide a dynamic way to store and manipulate collections of elements. Let's delve into the syntax and various operations you can perform on lists in Kotlin. So what I'm gonna do is first I'm gonna create a new project. Let's go to File, New Project, name it as Collections. So lists in Kotlin are ordered collections of elements. They can hold elements of any type and provide a range of useful functions for working with data. So what I'm gonna do is I'm gonna remove the by default code over here. Let's create, okay, in main only we are gonna do it, no issues. So let's create an initialize a list. So what I'm gonna do is over here I'm declare a global variable of list. So I'm gonna initialize a list numbers list type is int list of suppose 1 2 3 4 5. Now once this is basically creating and initializing the list. Now what I'm gonna do, I'm gonna access the elements in the list. So I could write something like println original list numbers. Once that is done, I'm going to access specific elements. Suppose if I have printed numbers, it will print all the elements. If I just try to run this, we'll wait for a few minutes. Okay, so these are all the elements in the list. Now suppose I want to access specific elements. Then how to do it? I'm going to say suppose val third element is equals to numbers box bracket, then the index, and there we go. So suppose I want to access, so the index of 1 of this position is 0, then it's 1 2 3 4. So suppose I want to access the number 4. Okay, so the index of the first element is 0, then 1, then 2, then it's 3. So I need to write 3 over here. Now in this case the third element is 3. For that I need to write 2 over here. Okay, because the index is 2. So it starts from 0 and it ends from n minus 1. So what I'm gonna do is I'm gonna just print it. So I'm gonna say third element done. So in this example we created an initialized list of integers using the list of function. We can access elements in the list, demonstrating how to retrieve a specific element. Okay, third element, great. Now let's take one more example in which the list operation such as size, contains an index of we are going to use. So what I'm going to do is just remove this thing and remove this global list also. Under this I'm going to say I'm going to create a list. First of all I'm going to say val fruits list of, make sure O is capital, apple, banana, orange, ORANGE, and then suppose one more apple. Okay, now once this is done, what we are gonna do is we are gonna print list of fruits. Done. Now suppose I want to get the size of the list. So how I'm gonna do, I'm gonna say suppose val list size is equals to fruits dot size. That's simple. Okay, now I'm gonna suppose print it. So I'm gonna say println size of the list size, done. So as of now the list size is 1 2 3 4, 4 elements are there, hence the list size is 4. Okay, now let's run the app first and let's see what's the output. Okay, the size of the list is 4. Great. Now suppose I want to check if the list contains an element or not, then how to do it? So I'm gonna say val contains banana. Suppose I'm gonna say fruits dot contains, I'm gonna say just copy this text banana and paste it over here. I'm gonna just check whether the list contains banana or not. I'm gonna print it. I'm gonna say contains banana question mark and contain banana. It will return a boolean value, okay, in true or false. Then suppose I want to find the index of an element, so how to do it? I'm gonna say val index of orange suppose. Then I'm gonna say fruit dot index of orange. Then I'm gonna print it. Index of orange. Okay, let's see what's the output for this. Here we showcase common list operations such as getting the size of the list, checking if an element is present, and finding the index of the specific element. Now if you see size of the list is contains banana, true, banana is there, great. Index of orange is 2, that is 0, 1, 2. Okay. Now suppose there are 2 apples in this, right? So suppose I try to just copy this thing and try to paste it over. Let's see what will be the output for this. Either what it should return. It should return either 0 or it should return either 3. But let's see what it will return and then I'm going to explain. Great. It is returning 0. That means the first element that the compiler will get, it will try to print that only. Okay. Great. So let's take one more example. This time we are gonna modify the list by adding and removing some elements. I'm just gonna remove this. Okay. Now let's create a list again. I'm gonna say val, suppose this time colors is equals to, I'm gonna say mutable list this time so that I could make all sort of changes. I'm gonna say red, I'm gonna say green, and I'm gonna say blue. Then I'm gonna print it. So mutable list is more or less similar to array list in Java, and the normal list is similar to arrays, okay, in Java. So this is, we are gonna print the whole list. Now suppose I want to add an element into it. So how to do it? I'm gonna say this, it's very simple. Colors dot add, name the color, I'm gonna say yellow, just copy this, print it over here, list after adding, I'm gonna say done. Now then we are gonna remove an element. So I'm gonna say colors dot remove green, just copy this, paste it over here, list after removing think it's done. Let's run the app and let's see. So in this example, we use a mutable list to demonstrate adding and removing elements from a list, showcasing the dynamic nature of mutable list. So the original list was with these three colors RGB, then we added yellow over here, and that's the list after adding yellow, and we removed green. So green is removed, we have only RBY. Okay. Let's take one more example this time. Okay. Now this time we are gonna do a list transformation using map and filters. Okay. So what I'm gonna do is remove. Okay. Let's do one thing. Map and filters. We are gonna do it in next lecture only. It's not an issue. We have a separate topic for that. Okay. Okay. So, and that concludes our exploration of lists in Kotlin. Lists are a powerful tool for managing collections of elements, offering a variety of operations to manipulate and transform data. Now go ahead, experiment with the list in your Kotlin projects and discover the flexibility they bring to your code. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin enthusiasts. Today we are exploring another essential data structure in Kotlin, sets. Sets provide a unique collection of elements ensuring each element is distinct. Let's delve into the syntax and various operations you can perform in sets in Kotlin. So let's take the first. So I'm just going to remove this, and the first example we are gonna create an initialize sets. Okay, so I'm just gonna create and initialize a set over here. I'm gonna say val, give a name to the set, unique number, set, it will be in type of int. Then I'm gonna say set of, and I'm gonna say 1 2 3 4 5 3 2 1. So sets in Kotlin are under-ordered collection of distinct elements. They are particularly useful when you need to ensure uniqueness in your data. Okay, suppose I want to just print this thing. I'm gonna say println original set unique number. So it will just print all the unique numbers. It will not repeat 3 2 1. 1 2 3 4 5 will be printed. It will not take 3 2 1. So in this example we created and initialize a set of integers using set of function. Note that duplicate elements are automatically removed, ensuring uniqueness in sets. Okay, here we go. Now let's take one more example. Let's remove this code. So in this example we are gonna get the size, then contains and is empty operations and sets. So what I'm gonna do is, let's go with the function. Let's create a function itself. I'm gonna say fun set operations. I'm gonna say let's create a set over here. I'm gonna say val colors set of red comma green comma blue okay, what's the problem? Now once that is done, I'm gonna print it, println. I'm gonna say set of colors. Then what I'm gonna do is I'm gonna say let's get the size of the set. So I'm gonna say color dot size. Now I'm gonna print this, so just copy this thing, paste it over here, say set sizes, copy this, paste it, done. Now check if the set contains an element or not. So I'm gonna say val contains red contains set contains red. Then again contains red question mark. And the next is checking if the set is empty or not. So I'm gonna say val is empty set colors dot is empty println is the set empty is empty. Just copy this set operations, paste it over here so that we could execute this function. Run this. So here we showcase common set operations such as getting the size of the set, checking if the element is present, and determining if the set is empty. Here we go. The set so this is the set that we have printed, okay, and then the size of the set, that is 3. Then okay, just copy this and paste it over here. Contains red, the value should return true, and is empty set, the value is false because the set had elements, so it's returning, it's not empty, it's false. Okay, great. So let's take one more example in which we are going to modify the set by adding and removing elements. Here we go, it's true. Okay, so what I'm going to do is I'm going to create one more function. I'm going to say fun set modification. I'm going to create sets, so I'm going to say val fruits. This time I'm going to use mutable set of. Then I'm going to say apple, banana and orange. Then what I'm going to do, I'm going to print this thing, println fruits. Then I'm going to add element. I'm going to say fruits dot add, suppose grapes. And again I'm going to print it. I'm going to say set after adding okay. Over here I'm just gonna say original set. And the next is I'm gonna remove an element from the fruit. So I'm gonna say remove. I'm gonna say banana, println set after removing I'm gonna say fruits. Just copy this function, paste it over here. Let's see what's the output. So in this example we use a mutable set to demonstrate adding and removing elements from a set, showcasing the dynamic nature of mutable sets. Here we go, original set was this, then after adding grapes we have this, and then after removing banana we have this set. Okay, make sure when we are adding and removing elements we need to use mutable set over here. Okay, now let's take one more example in which union, intersection and difference example we are going to take in sets. So I'm going to say fun set operations. So let's make a set. So I'm gonna say, let's make two sets. Set 1, I'm gonna say set of, I'm gonna say 1 2 3 4 5, and other set is set 2. I'm gonna say set of, I'm gonna say 3 4 5 6 7 suppose. Okay, why this is red? I don't know why this is red. Okay, set operations over here and set operations over both with the same function. That's the reason. Okay, so what I'm gonna say is set op. I'm gonna say the function will be set op. Now what I'm gonna do is I'm gonna do the operations of union of two sets. So I'm gonna say val u1 i1 union set is equals to set 1 dot union set 2. So what does this mean is all the elements which are basically present in this and this, all the elements that are present in this and this, we are going to show it. Okay, and no repetition will be done, of course. So suppose 1 2 3 4 5 is present and we have 6 7. Okay, so 1 2 3 4 5 6 and all the unique elements we are going to show present in both the elements. Okay, union means this. Then what I'm going to do, I'm just going to print it. I'm going to say union of sets, and then union set done. Okay, now we are gonna do the intersection of two sets. So I'm gonna say val intersection set is equals to set 1 dot intersect set 1 intersect set 2, and same I'm gonna print it, intersection of sets. I'm gonna say intersection set inter secti1 intersection of sets. Now we are gonna take the difference between two sets. Intersection is basically the common elements, that is 3 4 and 5 are basically common in both these sets, so these three will, we are gonna print it. Okay, now we are gonna see the difference between two sets. So what I'm gonna do is I'm gonna say val difference set is equals to set 1 dot subtract set 2, and then I'm gonna print ln difference between sets, different sets. So what does this mean? Set 1 subtract set 2, that whatever element set 2 has, we are going to print all the elements of set 1 provided the elements are not present in set 2. So we are going to print just 1 and 2 because 3 4 5 are present in set 2, hence only 1 and 2 will be printed. Okay, so what I'm going to do is just copy this thing and paste it over here, and let's see what's the output. Here we explore set operations such as union, intersection and difference, providing ways to combine or extract elements from two sets. Here we go. So the union is 1 2 3 4 5 6 7, that is all the elements combining both these sets, all the elements, all the unique elements. So 1 2 3 4 5 6 are the unique elements. Now the intersection means all the common elements. The common elements in both sets are 3 4 and 5, right? 3 4 and 5. And then the subtract, so the elements that are not present in set 2, okay, and the elements, first of all the elements that are present in set 1 we are going to take, that is 1 2 3 4 5, and we are going to check if the elements that are not present in set 2, so 3 4 and 5 are present in set 2 and 3 4 are also present in set 1. Hence we are going to remove this and only the unique elements of set 1 we are going to take. Now suppose I just want to change it to set 2 over here and set 1 over here, so 6 and 7 must be printed. Okay, 6 and 7 is getting printed because 6 and 7 are unique to set 2. Great. And that concludes our exploration of sets in Kotlin. Sets are a valuable tool for managing collections of distinct elements, ensuring uniqueness. Now go ahead, experiment with sets in your Kotlin projects and enjoy the benefit they bring to maintain unique data. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin learners, today we are delving into the world of maps, a powerful data structure in Kotlin. Maps allow you to store key value pairs, providing an efficient way to associate values with unique keys. Let's explore the syntax and various operations you can perform on maps in Kotlin. So what I'm going to do is, I'm going to create a new, let's go to Kotlin class of file, select file over here. Then I'm going to say maps. I'm going to say fun main. Then press enter. Over here I'm going to create my map and initialize a map. So I'm going to say val fruit prices map. Map is basically a combination of key and value. So the first will be key, that is key will be in the form of string I'm saying, and the value will be of double. And now I'm going to say map of map, make sure the O is capital. Apple is the key and the value of apple is 2 1.0. Okay, so 2 basically combines both the key and the value. It merges the key and the value. Okay, now let's press comma, and I could say, sorry, now I could say banana 2 0.75 comma orange to 1.25 suppose. Okay, I've created and initialized a map. Now what I'm going to do, I'm going to print it. So I'm going to say println original map fruit price. Done. Just run the app. In this example, we created and initialized a map of fruit prices using the map of function. The keys are strings representing fruit names and the values are doubles representing their prices. Great. Let's take another example in which we are going to do the map operations such as size, contains key and contains value. What I'm going to do is just remove these things. I'm going to create one more function over here. I'm going to say fun map operation. I'm going to say var car model map of, suppose map of 2022 to model y, comma 2021 to model 3, and then 2020 to model S. Okay, so these are the key and these are the key value pairs. Okay, now what I'm going to do, I'm just going to print it. I'm going to say print I'm gonna say map of car models. Now I'm gonna get the size of the map, so I'm gonna say val map size is equals to car model dot size. That's it. Print it. Map size done. Then what else? Now we are gonna check if the map contains a key or not, so I'm gonna say val contains 2021 is equals to car model dot contains key. Put the value of key, that is 2021, and print it. It will return a value of true and false. Contains key 2021 contains 2021. Okay, great. Now one more, if you have noticed over here, that over here we have not used this kind of a syntax such as car model, then map string, or this time it's an integer, so int, and then the value string. So we could use this. Otherwise, if we are not using this, then also the compiler will understand, okay, this is an integer and basically this is a string. But we need to make sure that all are uniform. So suppose if I do a string, it will show red. We need to make sure that all the elements are basically in the form of integer and string only then. Okay. I'm just gonna remove this. Okay. Now what else? Key contains is done. Now we are going to check if the map contains a value or not. So I'm going to say val contains models are there, model S suppose. I'm going to say car model dot contains value model S. Println, I'm gonna say contains model S contains model S. Make sure you copy this and paste it over here. And yeah. So here we showcase common map operations such as getting the size of the map, checking if a key is present, and checking if a value is present. Okay, so we have all the map size is there, contains 2021, it's true, and contains S model, that is also true, in which we are gonna do map modifications by adding and removing the entries. So over here I'm gonna say fun map modification. I'm gonna create a map of student grades, then I'm gonna say mutable map of Alice to 95, Bob to 87, Charlie to 92. Done. Now I'm gonna print it. I'm gonna say print ln original map of grades, student grades. Now what I'm gonna do is I'm gonna add the elements. So I'm gonna say student grades. Suppose I need to add an element over here. I'm just gonna say suppose David. Put the value over here. Done. That's simple. Now I'm gonna say map after adding David's grade. Student grade. Done. Now I'm gonna remove one, so I'm gonna say student grade dot remove. Just enter the key. That is suppose Bob I'm gonna remove. Now just print map after removing an element. I'm gonna say student. Just copy this, paste it over here, run this. In this example, we use a mutable map to demonstrate adding and removing entries from a map, showcasing the dynamic nature of mutable maps. Okay, so I have these elements. Now after adding David's grades, I have David's grades as well over here, and we are gonna remove the Bob. So Bob marks and name is basically removed. So these are basically the uses of maps. Now let's iterate over map entries. Okay, how to do it? Let's create one more function. I'm gonna say fun map iteration. I'm gonna say map country country populations map of USA 2, make sure 2 is small, USA 2331, then China 21441, India to suppose one, take any example, 1393. Now I'm gonna iterate over the map entries and print key value pairs. So how to do it? I'm gonna say for country, comma population in country population. So each time the loop will contain, suppose the first iteration will contain these elements, then the second iteration will contain these elements, sort of like this. The first iteration will contain these elements. Within these elements we have a key. So the key is basically will assign to country and the value will be assigned to population, and we can use it like this. So I'm gonna say print ln, I'm gonna say population of country, population million. Okay, so this country is basically this one and this population is this one. So each iteration, first iteration will have this value, this whole value, in which the USA will be assigned to the country and 331 will be assigned to the population. Okay, that's sort of like this. So just copy this thing, paste it over here. Let's see what's the output. Here we demonstrate iterating over map entries using a for loop, extracting and printing key value pairs from the map. Here we go. Population of USA 331 million, China is India this much. Okay. And that concludes our exploration of maps in Kotlin. Maps provide an efficient and effective way to store and retrieve values based on unique keys, making them a powerful tool for data association. Now go ahead, experiment with maps in your Kotlin projects and witness the convenience they bring to managing key value pairs. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin enthusiasts, in today's course we are delving into the world of functional operations on collections. These operations empower us to write concise and expressive code, transforming the way we work with data in Kotlin. We get ready to explore the beauty of functional programming in collections. What I'm going to do is create a file. Click on that file and let's go with functional operations. Now once that is done, I'm going to say fun main. Okay. Now, so functional operations on collections are a set of powerful tools in Kotlin that allow us to perform operations like mapping, filtering, and reducing on collections in a functional and concise manner. Let's dive into the details. Let's do a map operation. Let's create a function, suppose map operation. Okay, so what's the error over here? Let's create a variable. I'm gonna say list of and 5. Now once that is done, I'm gonna say, suppose I need to square all the numbers that are present in this list. So how to do it? I'm gonna say val squared numbers. I'm gonna say numbers dot map. I'm gonna say it into it. Okay, and then I'm gonna print it. I'm gonna say println original numbers and then again println I'm gonna say square numbers done. I don't know what's the issue with this. Copy this thing, paste it over here. Fun main, I don't know what's the problem. Okay, let's run the app and let's see what happens. I don't see any issue. Let's see. So in this example, the map operation is used to square each element in the list. The concise syntax of Kotlin allows us to transform the entire collection effortlessly. Okay. Conflicts, overloads. Okay. So map operations, let's use S over here. Okay. So an overload was occurring actually. That means a by default function was available already in the Kotlin library, which was causing this issue. Now it's resolved. So you will see the output in squared numbers as all the outputs will be squared. Okay, here we go. We squared numbers. Okay, so this is how you could basically directly do all the things, all the operations. Now let's take a second example in which filter operations we are going to use. We are going to do filter operations. I'm going to say filter operations. I'm going to say val numbers is equals to list of 1, 2, 3, 4, 5. Then I'm going to say, suppose I want to get all the even numbers in the list, so I'm going to say even numbers is equals to numbers dot filter. I'm going to say it modulo sign 2 is equals to 0. That means okay, sorry, I need to use curly braces over here. So basically I will iterate through all the numbers and I will check whether 2 by dividing it by 2 I'm getting the remainder as 0 or not. If this value satisfies and gives the result as true, then I will assign the value to the even. And then I'm gonna say original numbers, then I'm gonna say println even numbers, just copy this, paste it over here, try to run it. The filter operation helps us easily select elements from the collection that satisfies a given condition. Here it filters out only the even numbers from the list. Here we go. Okay, great. Let's take one more example in which we are gonna go with the reduce operation. So I'm gonna say fun reduce operations. Then I'm gonna say val numbers is equals to list of 1, 2, 3. Okay, let's do it again. Val numbers list of 1, 2, 3, 4, 5. Then I'm gonna say, suppose I need to get the sum of all these numbers, so 1 plus 2 plus 3 plus 4 plus 5. What is the sum of all the numbers I need to get? So how I'm gonna say, I'm gonna say val sum is equals to numbers dot reduce I'm gonna say ACC. So ACC is basically stands for accumulator. Okay, so I'm gonna tell you how this thing works. So I'm gonna say ACC, I'm gonna say number, make sure it's not S over there, number, I'm gonna say ACC plus number, make sure curly braces are there again. Okay, then I'm gonna say print ln original numbers println sum. Okay, so how this will work is, initially the accumulator value would be 0, okay, and the number would be 1. So 1 will be here, and accumulator value is 0, and number value is 1. So 0 plus 1, that is 1. It will assign the value to number, and that will be assigned to the accumulator. Okay. Now the compiler will come to the second element. In the second iteration, the ACC value is 1, and the number is 2 basically. So 1 plus 2, that is 3, and the compiler will copy that value to the accumulator. Now the accumulator value is 3. Now in the third iteration, the accumulator value is 3 and the number is 3, right? So the in the third iteration, after the third iteration, the accumulator value is 3. Similarly, it will work according to it. Okay, just copy this reduce operations in the main function and try to run the program. The reduce operations is perfect for aggregating values. It combines elements in the collection using a specified operation. In this example, it calculates the sum of all the numbers in the list. Here we go, 15. And there you have it. Functional operations on collections in Kotlin provide an elegant and expressive way to manipulate data. By mastering these operations, you can write code that is not only concise but also more readable and maintainable. So go ahead, explore the possibilities and enhance your Kotlin programming skills with functional programming on collections. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin learners, today we are diving into the power of collection functions in Kotlin. These functions like filter, map and more allow us to manipulate data in a concise and expressive way. Get ready to explore the world of functional programming with collections in Kotlin. What I'm gonna do is I'm gonna create a new file, so a new Kotlin class file, make sure it's a file, and over here I'm gonna say collection ct collection. Now once that is done, so the first example I'm gonna go with is the filter function. Okay, so the filter function I'm gonna create, first of all let's create a fun main. Then for the filter function I need to create a data class of person. Okay, so just go to Kotlin, just go to new, let's create data class, name it as person for now. Okay, now this person data class will contain a name which is a form of string. Then I'm gonna go with val age, which is a form of int. Once that is done, come to collection. I'm gonna create a fun over here, create a function over here, call it as filter function, filter fun. Now let's create a sample list of persons. So I'm gonna say val persons is equals to list of, I'm gonna say person Alice, comma age is 25. I'm gonna say person Bob, comma 30, person Charlie 22, person David 35, and person Eve would be 28. Okay, so these are the 5 examples with elements which I am gonna take. Now once that is done, I'm gonna filter the persons which are older than 25. Okay, so how to do it? I'm gonna say val older than 25 is equals to persons dot filter. I'm gonna say it dot age is greater than 25. Okay, and then I'm gonna simply print it. sorry, person older than 25 rather than 25. Okay, so I've created 6 elements, 5 elements. Okay, and once that is done, what I've done, I've filtered it by using it, that is iteration. So it will go through all the uh, elements one by one, and the age, so I'm checking the age. So if you just go to person, age is there, and we have created person over here, right? So dot age greater than 25, if it's true, then it will assign the value to the older than variable, and which we are printing. Just copy this thing, paste it over here, try to run this. In this example, we use the filter function to select persons older than 25 from a list of individuals. Here we go, person Bob, age is 30, David, age is 35, and Eve, age is 28. Great, the filter is done. Great. Now let's go with one more example in which we are gonna go with the map functions. Okay, so we are gonna use the same person data class. Over here, I'm gonna create a list of names from the original list. Okay, so what I'm gonna do is I'm gonna say fun, because I will create a new function for this. I'm gonna say map fun, map fun. Just copy this, sorry, just copy this list, and what I'm gonna do is I'm gonna get all the names from the original list. From the person name, I'm just gonna get the name and print it. Okay, not the age, I'm just gonna get the names. So I'm gonna say val names is equals to persons dot map it dot name. That's it. Then I'm gonna say print in list of names done. In this example, the map function is utilized to create a new list containing only the names of persons from the original list. Great, I'm just getting the names over here. Great. Now suppose let's take one more example in which we are gonna use any and all functions. Okay, I'm gonna say fun any and all fun. Okay, so for this same samples we are gonna take, just copy that and paste it over here. What I'm gonna do is I'm gonna check if any person is older than 30 or not. So I'm gonna say val is anyone older than 30 persons dot any, make sure it's curly braces, it dot age isn't 30. Print it. Is anyone older than 30? So if you see in the previous we are using filter, right, just to get this if anyone is older than 25, but over here I'm getting I'm using any is basically a boolean which will return true or false. That's it. Okay, now let's go with one more. We are gonna check if all person are younger than 40 or not. So I'm gonna say val are all younger than 40. persons dot all it dot age less than 40. If all are less than 40, then only the value of this will be true, otherwise it will be false. Okay, I'm gonna print ln. I'm gonna say are all persons younger than 40. Okay, done. Make sure you put it in the main function, try to run it. In this example, we use the any function to check if any is older than 30, and all functions to check if all the persons are younger than 40. So if you see, is any older than 30? True. That means we have a person, that is David, which is older than 30. Okay, so it is returning true. Are all persons younger than 40? True, because no one's age is more than 40, so it's returning true. Okay, and there you have it. Collection functions in Kotlin open up a world of possibilities for data manipulation. Whether you are filtering elements, mapping properties, or checking conditions, these functions empower you to write clean and expressive code. So dive in, experiment with these functions, and elevate your Kotlin programming skills. Happy coding, meet you in the next lecture. Thank you. Hello Kotlin enthusiasts, in today's course we are exploring the art of chaining operations in Kotlin. Chaining allows us to perform multiple transformations on our data in a single elegant expression. Get ready to witness the beauty of combining operations seamlessly in Kotlin. What I'm going to do is I'm going to create a new Kotlin file, name it as chaining. Hit a main function. Done. So chaining operation in Kotlin is a powerful technique that allows us to combine multiple operations on collections, making our code more concise, expressive, and readable. Let's take a simple example of chaining map and filter operations. Okay. So what I'm gonna do is I'm gonna take this person data class which we have created in the previous lecture, and we are gonna use it. Okay. Just remove that collection. Make sure chaining and person is only there. Now I'm gonna what I'm gonna do is I'm gonna just come to collection, just copy this, come to chaining, create a function, call it as function fun chaining map, paste that list in this, and then what I'm going to do is I'm going to select the names of person which are older than 25. Okay, so I'm going to say val names of older than 25 is equals to persons dot filter. I'm going to say it dot age greater than 25 dot map it dot name. So what it will do is it will give all the person, this line will give all the person name whose age is greater than 25. Okay, then what I'm gonna do is I'm just gonna print it, names of persons older than 25. I'm gonna say names of older person 25. Oh, great. Let's run the code. Let's see what happens. Before that, make sure you copy it, the function over here, and run it again. In this example, we chain the filter and map operations to first filter the person older than 25 and then extract their names. Okay, here we go. Names of person older than 25: Bob, David, and Eve. Great. Now let's take one more example in which chaining, flat map, and distant operations we are gonna deal with. So what we are gonna do is I'm gonna say fun data class. Let's create a first data class. I'm gonna say new Kotlin. Make sure it's data class. Create a data class of book. Suppose over here I'm gonna say val book has a title, which will be a form of string. Then authors, which will be in the form of list. Great. Once that is done, there are two variables, that is one is string and one is the string in the form of list. Now what I'm gonna do is create a function, name a function, suppose uh, chaining flat map. Over here what I'm gonna do is I'm gonna create a sample list of books first. So I'm gonna say val uh, books is equals to list of, I'm gonna say book Kotlin in action. Then I'm gonna say list of geometry raw and Svetlana Isakova. Once that is done, use comma, then again a book title. Let's take one title. Let's take, suppose, effective Java. I'm gonna say list of Joshua Clutch. Next book. What else we could take? Suppose clean code. List of geometry again, Samarov, comma, Svetlana Isa. Okay, make sure it's the same. Okay, what's the issue with this? Okay. Done. So we have used 3 elements. Okay. Now what I'm gonna do is, now I'm gonna chain it. So I'm gonna chain extract distant authors from all the books. Okay, I'm gonna extract all the distant authors. So I'm gonna say distinct authors is equals to book. So all the authors I'm gonna get it, all the distinct authors. I'm gonna say flat map. I'm gonna say it dot authors. So if I use this, that means I will get all the authors, and it may repeat these two authors as well. So I will have 1, 2, 3, 4, 5 authors I will have, but not distinct. So for distinct I need to do distinct. Once that is done, I'm gonna print it. I'm gonna say println. I'm gonna say distinct authors from all books. Distinct authors done. Just copy this function, paste it over here. I think we are set to. So in this example, we chain the flat map operation to flatten the list of authors and the distinct operation to get unique authors from all books. Here we go, distinct authors from all books. Great. Okay. So if you see, Dmitry Gemrov, there is one E missing over here, and there is one E over here. That's the reason I think it's not same. Let's remove this E and let's run it again. Now in the next example, we are gonna go with chaining custom operations. Okay. Let's first see the output. Okay. Now there are three outputs. Great. It's working. Now let's create one more data class for the next example. So I'm gonna create new Kotlin data class. I'm gonna say this time product. I'm gonna give a val name over to it, which will be a form of string val price, which will be a double. Done. Make sure there are no errors. Okay, done. Come to chaining. Now suppose give a function name fun uh, chaining custom operation. Now what I'm gonna do is I'm gonna take some sample products. So I'm gonna say val products is equals to list of, I'm gonna say product name, suppose laptop, and the price of the product, suppose that was double, I think. Yeah, this is double, so $0 just copy this 4 times, suppose 4 things we are gonna buy. Make sure comma there. Oh, done. Now I'm gonna say mouse, keyboard, last I suppose laptop tag, change the price to $30. I think $30 would be nice. 80 and $50 back. So what I'm gonna do is I'm gonna apply 10% discount to all these products, and I'm gonna sum it for the billing. Okay. So I need to apply 10% discount on each and every product. Then I'm gonna sum all the products, and then I'm gonna print it. So what I'm gonna do is I'm gonna say val total price after discount, discount products dot filter it dot price. So I'm gonna check whose price is greater than 50. Those only I'm gonna give the discount. I'm gonna say dot map the product whose price is greater than 50. For those I'm gonna apply a discount into 0.9. So what I'm gonna do is, so what I am doing over here, so whosoever price is greater than 50, I am giving a 10% discount to it. So I am just assigning the 90% value to it. So suppose 80 is greater than 50, right? So I am multiplying 80 into 0.9, that is 72. So I'm assigning the value to keyboard as 72, sort of like this. Okay. And then what I'm gonna do is I'm gonna sum it. So I'm gonna say sum. That's it. Now I'm gonna println. So a lot of manipulations actually you can do with chaining. A lot of different things are there. You need to try all the examples. You need to know all the examples. Discount COUNT. In this example, we change the filter, map and some operations to calculate the total price after applying a discount to products with a price greater than 50. Great. 1152 is the price after all the discounts whose products price is greater than 50. Great. And there you have it. Chaining operations in Kotlin enables us to create powerful, concise and expressive code. By combining operations, we can perform complex transformations in a single readable expression. So embrace the beauty of chaining in your Kotlin project and witness the elegance it brings to your code. Happy coding. Meet you in the next lecture. Thank you. Hello Kotlin learners. Today we are delving into the crucial topic of handling exceptions in Kotlin. Exception handling is a fundamental aspect of writing robust and reliable code. Get ready to learn how Kotlin empowers us to manage exceptions gracefully and make our programs more responseless. So what I'm gonna do is I'm gonna first create a new project. Just go to file over here, new project, name it as exception handling. Kotlin IntelliJ, create it. What's the issue? Old file, new project, and what was the issue? So exception handling is the process of gracefully managing unexpected situations that can arise during the exception of a program. In Kotlin, we have powerful tools to catch, handle, and even create our own exceptions. So what I'm going to do is under src, under main, under Kotlin, create a package over here, new package, name it as handling exceptions. Now let's create a new Kotlin file over here. So just go to Kotlin, make sure it's a file, and over here I'm gonna say recipe exception. Now what I'm gonna do, I'm gonna say fun main. There's one class. Now what I'm gonna do in the under this class is I'm gonna say try, and then I'm gonna say catch e io exception. So this is basically syntax of try and catch. Now I'm gonna write the code which I think the crash maker. I'm gonna write that code over here. So I'm gonna say val file. Suppose I want to read a file. I'm gonna say file. I need to write the path of the file. So under this exception handling, okay, so what I'm gonna do under this Kotlin, I'm gonna say a file name example, suppose example.txt. and write some name. So my name is Karthik. This is the file, normal file, okay, normal txt file. Now give the path. So I'm gonna say src slash main slash Kotlin slash example dot txt file. Click on this option, enter. Then once I got the file, I'm gonna read the file. So I'm gonna say reader is equals to file reader file, pass the file over here, and now perform the reading operation. Suppose I'm just gonna say println file read successfully, and I'm gonna close the reader. Okay. Now if suppose any sort of an exception occurs, so I'm gonna say println error reading the file e dot. So whatever the message, whatever the error message is, I'm gonna get it over here. Okay, I think this should work. Let's run the app and let's see. From this example, we use a try catch block to handle a checked expression that might occur while reading a file. This ensures that if an exception occurs, it is caught and can be handled appropriately. So the compiler will try to execute this code first. If any sort of a crash occurs, then automatically the compiler will execute this. So file read successfully. Now suppose I want, if I just suppose change the path, suppose I'm removing this Kotlin over here. Now a crash must occur. So the compiler will first try to fetch this line, but ultimately the crash will occur. We are going to debug this and we are going to see how this thing works. So error reading the file, this no such file or directory. This is the exception that it is throwing in e.message. So just add points over here, this red points, just click on this, okay, and we could see how the code will run actually. Okay, now just click on this debug and we'll see how the compiler will try to execute this code. Okay, so for now the compiler is basically over here, okay, and we need to move forward. So just click on this, okay, the compiler is here and we'll try to execute this code. Okay, no problem is there. Now the crash must occur here in the reader when the compiler will try to read the file. Okay, the error occurred here because no such file is available, and the compiler will directly come over here in the catch and will try to execute this. Okay, after this catch the compiler will try to execute this line and will come out of the try and catch. It's sort of like this. Okay, great. Let's take one more example. So over here I'm gonna create one more example, name it as Kotlin, make sure it's file, and over here I'm gonna say handling unchecked exception on main. Suppose I'm gonna use try. Sorry. Catch e, suppose this time arithmetic exception, and what I'm gonna do over here is I'm gonna say val result 10 divided by 0, that is basically, this will throw an error. I'm gonna say result, whatever the result is. And then what I'm gonna do over here, I'm gonna print it. So I'm gonna say println error e dot message. Okay, let's see what's the output for this. So here we intentionally created an unchecked exception, arithmetic exceptions for division by 0 within a try-catch block to demonstrate handling such runtime exceptions in Kotlin. Okay, error divide by 0 error it's showing. Now if suppose I don't know what sort of an error it will throw, so I could directly write exception. It comes, okay, and then if I run, so if I use exceptions, it could handle everything, so you don't have to think much about it. Okay. So now let's take one more example of by using finally block. Okay, let's create one more file over here. Finally block. Now what I'm gonna do, I'm gonna create a file reader over here. So I'm gonna say var file reader, file reader null. Just click on this option, enter, import class file reader, done. Now what I'm gonna do is I'm gonna say try. I'm gonna say val file is equals to file, so it's src slash main slash kotlin slash example dot txt. Click on this option, enter, so that I could import the library. Then I'm gonna print the file. Before that I'm gonna create a reader, so file reader is equals to file reader, I want to say file, then println, I'm gonna say file read successfully, done. Now what I'm gonna do, I'm gonna use a catch over here. I'm gonna say e io exception. I'm gonna say println error reading the file e dot message. Then I'm gonna use finally. So suppose the compiler will try to execute this file, and if any sort of an error occurs, it will try to execute this file, and then finally this code will occur. So if the error occurs or not, it's independent. Finally will occur after, if suppose there is no crash occurring, so the compiler will try to execute these 3 lines, and then the finally code will execute. Otherwise, if some sort of an error occurs with these 3 lines, the compiler will first try to compile this line and then the finally line. Okay, I'm gonna say finally, I'm gonna close the reader file. Sorry. Okay, and then I'm gonna print it. So I'm gonna say println cleanup operations in the finally block. Okay, let's run the code. So in this example, we introduce the finally block, which is executed regardless of whether an exception is thrown or not. It is commonly used for cleanup operations such as closing resources and all. Great. File is read successfully and then the cleanup operation is done in the final block. Great. So and that concludes our exploration of exception handling in Kotlin. Exception handling is a critical skill for writing robust software, and Kotlin provides us with clean and concise tools for managing unexpected situations. So go ahead, practice handling exceptions in your Kotlin project and ensure your code is equipped to handle the unexpected. Happy coding. Meet you in the next lecture. Thank you. Hello, Kotlin enthusiasts. Today, we are unraveling the mystery of nulls in Kotlin and exploring the powerful features of null safety. Nulls can be a source of bugs, but fear not. Kotlin null safety mechanisms are here to guide us in writing more robust and reliable code. Let's delve into the world of null safety. So what I'm gonna do is I'm gonna first take one example and just go to main over here. Remove the unnecessary code. Create a function over here. Nullable types. I'm gonna say var nullable string. It's the name of the variable. Then I'm gonna use string and then make sure you use question mark and then hello Kotlin. Okay. Now what I'm gonna do, I'm gonna print this statement. Suppose nullable string only I'm directly. Okay. And now what I'm gonna do, I'm gonna assign the value as null to this nullable string, and then I'm gonna print this statement again. Just copy this and paste it over here. So initially, let's see what will happen. Okay, I am printing the statement with a value and then I'm assigning null and then I'm printing. Okay, let's see what's the output. In this example, just copy this and paste it over here only. Call the function in main. So in this example, we declare a nullable string that can hold either a string or a null value. This flexibility allows us to represent the absence of a value explicitly. Okay, hello Kotlin and then null. Suppose I remove this nullable string to a normal string. Now if you see, an error is coming out, right? So this is the actual use case of this question mark. Great, once that is done, let's move to some more examples. This time we are gonna use safe calls. So I'm gonna say fun safe calls. I'm gonna say val text string nullable string null. Then I'm gonna call the safe operation, safe call operation. I'm gonna say val length int text length. Okay. GTH. Okay. So this is basically safe call. This one. Okay. I have assigned null safety over here to this text. Okay. And I'm basically, so if I'm assigning a null safety, make sure if any sort of an operation I'm doing to some other variable, make sure that is also with the null safety, because this could be a null, right? And if I'm saying null dot length, then it will return null only. So you need to make sure that this length is also a type of null. Okay, and this is called the null safety. Now what I'm gonna do, I'm gonna print ln length of the text length. copy this, paste it over here. Let's see what's the output. Here we use the safe call operation, that is question mark dot, to safely access the length property of the nullable text variable. If text is null, the result is null, otherwise it gives the length of the string. Okay, so the length of the text is null. Great. Now let's take one more example by using Elvis operation. So I'm gonna say fun Elvis operation. I'm gonna say val name string null. Then the Elvis operation I'm gonna use, so I'm gonna say val length is equals to name length. Now this is the Elvis operation. So what is Elvis operation? So I'm saying if the length is null, I'm gonna assign -1 to it, but not null. Previously over here we are assigning null to the length, but over here if the length is null, I'm gonna assign -1 value. Okay, so this is Elvis operation. So I'm gonna say println, I'm gonna say length of the name The Elvis operation allows us to provide a default value of the expression before it evaluates to null. In this example, if name is null, the length is set to -1 as a fallback. Great. The length of the name is -1. Great. Now let's take one more example, that is safe casting. So what I'm going to do, I'm going to say fun safe casting. I'm gonna say val text. This time I'm gonna use any operator, suppose, so any data type, hello comma world. Then I'm gonna call the safe cast operation, so I'm gonna say val length int text as string, calling the save calls, done length, and now print the length of the, just copy, I'm just copying this thing, the same. Okay, so what I'm doing over here, I'm saying create a text of type any, it could be any type. Now as of now it's string. Okay, now I'm saying because it's any, right, and this is a form of int, right, so I'm saying any as string, take it as string, and then get the length of it. Okay, now if suppose I just make it as 3 4 5 6. Okay, so here we go, this is showing some sort of an error. Now just copy this thing, let's see what output we are gonna see. Okay, so just undo this, let's see what's the output, and we are gonna explain according to it. So safe cast helps us safely cast types. In this example we use it to cast text to string and then obtain its length, ensuring safety even if the cast fails. Okay, the length of the name is 13. Great. Now if suppose I just remove this string and if I place 3 4 5 6, now let's see what happens. Okay, the length of the name is null, showing null. Great. Okay, this is what the expected output must be. Now, and there you have it. Kotlin's null safety features provide a shield against one of the most common source of bugs. By embracing nullable type, safe calls, the Elvis operator, and safe cast, you can write code that is more resilient and less error prone. So go ahead. leverage null safety in your Kotlin projects, and enjoy a smoother coding experience. Happy coding. Meet you in the next lecture. Thank you.